All right, so listen, I want to see how alert you guys are tonight. Can anybody see anything wrong here with this picture? Just want to see how alert you are. Reverse, but the car runs. How did it run? It runs. Car starts and runs. Perfect. No problems. What's that? Charge the battery incorrectly. It was totally dead. See? Had to be totally dead. Exactly. I was mesmerized. I'm like, dude, did you put the cables on backwards? He goes, no, that's the way it is. I'm like, but it's negative and positive. Oh, so what happened? They charged the battery backwards. But that's just my visual, lifting the hood up and looking around. And a lot of times when you look around, you can diagnose a lot of cars and find problems just using the 5 sense diagnostics. And the key thing is you need to be very, very alert when you're working on cars. You just don't know. I mean, I saw this. Another guy could look at the engine compartment. He won't see it because he's not really looking around. So, yes.
What was the actual complaint on that car, though?
Well, I went there for other reasons.
Oh, okay.
Okay? But I happened to see that. And I was like, how's this car running? I was mesmerized by it. Yeah, but it's the fact that the battery went all the way down to nothing. And they charged it backwards. Wow. Polarized it backwards. And it worked. So just being visual and understanding that things happen out there that are not normal. And a lot of times when you're using manuals to diagnose cars, they don't always take you where you have to go because you're working on cars that have been altered. And that's my key thing here. So just keep it simple and do not get too technical. All right? Problem solving. You know, the whole thing of any problem with any car. So we have basically we're going to talk about the ECM tonight and talk about any kind of control module, how they work. But there's other things in the mix that can throw you a lot of curveballs. Parts are a big problem now. When you get a part from an auto store, even a dealer, there's no guarantee that it's the correct part or whether it's going to work for that vehicle. It could be one number off, or maybe the guy looked up wrong. So the parts guy can be your best friend or your worst enemy. I'm here to tell you, when you buy any part, you need to check this part and really look it over very well and question your parts guy. You're going to have to. So if something doesn't look right, you need to start questioning. Also, equipment. You know, I mean, I'm not knocking aftermarket scan tools, but I'm just telling you there are bugs. There is no scan tool that does not have a bug aftermarket. And the thing is, I'll give you an example. I got burned twice. I mean, I'm using an aftermarket scan tool. I'm not going to mention what it is. I've just been playing around with it. And I'll give you 3 scenarios. How would you like to go to a shop and you get a simple problem of a steering angle sensor fault? And the value is negative. So the steering wheel is straight, and the value is negative, like negative 300. So then you cut the wheel, and there's no reaction. So I'm like, well, let me just go in and try to calibrate the steering sensor, which is a common thing. When batteries go dead, you know, when you get the situation on the car, you know, disconnecting the battery is nothing. It's dragging the car down to nothing. You don't ever want to do that because you'll be married to all kinds of problems of calibrating stuff, losing memory on certain computers for other features. But, you know, I went in and I went to initialize the steering angle sensor to calibrate it, and, you know, it didn't work. So I'm like, well, the wiring is good, so it has to be something wrong with the sensor. I'm not going to condemn the computer. So we put the sensor in, hooked the tool up again. I had to go back the next day because he ordered the part, put it in, and I hit the button, same thing. I'm like, you know what? Let me just get the factory tool. I just thought it was easier to hook this thing up and just do a quick one. Hook up the factory tool, wheel straight, hit the button, it's done like this. Oh my God. So, and I'm like this, oh my God. What do you do in that situation? So had I not had a factory tool, I wouldn't know. So, and that's just one bug that's in that tool. How would you like to pull a code and it says right side seatbelt problem, right? So I have the guy rip apart the whole right side. I'm checking the voltage in the lines. I'm checking the sensor. I'm like, nothing's wrong here. Something just doesn't jive. And the thing is, I never looked the code up in all data. I just saw the code and I saw the definition. Let me hook up the factory tool just in case maybe it's something else that's not picking up. I pick it up, same identical code, but the definition was for the opposite side of the car. So I ask you, how is that possible that the scan tool pulled the code and the information was wrong? How is that possible?
Somebody entered it wrong.
Who entered it wrong? So do you think that definition comes out of the car computer, or just the code comes out of the car computer?
Just the code.
So, and you ever see a tool that says code undetermined, undocumented? It's all about the library tool. So I want you to understand that when you're pulling any code in any car, you need to go into an information system and find out what the code is, and find out if that is the exact definition of that code. You know, and it just happens. And I never knew all this stuff was there until I started playing around with this tool. I want to, you know, I need other stuff. Sometimes I need stuff that's quick. But now I have to sit there and start questioning my tool. And that's a bad thing. So I'm just telling you, be alert and understand that when you pull a code, you need to look that code up and find out code strategy, why this guy set the code. And what is the code for? So just be alert with that. I don't want you to get burned like I did. Information systems, same thing. And I was mesmerized the other day. The guy worked on he had a Bank 1, Sensor 1, O2 sensor on a Nissan. That's the one that has the exhaust manifold, and they split it in half. They make the front Bank 1 and the back Bank 2. Well, I don't know. Just put one sensor and make Bank 1. But they split the manifold in half, and they screw one over here for cylinder 1 and 2, one over here for cylinder 3 and 4, and they call this Bank 1, and Bank 2. So he got a code for Bank 1, Sensor 1, but he's like, it's a green wire. And if you look at the diagram, which is supposed to be factory, it showed a white wire for Bank 1, Sensor 1. So I'm like, dude, I think maybe these are backwards. Someone crossed the wires. He goes, no, I followed all the way up and I did something else. It was interesting. He unplugged the other one and got a code for Bank 2 sensor. So if you're not sure, you can always create a code on the other guy and see what code he creates. So he knew that was Bank 1. He goes, no, all that is wrong. I know it's wrong with this car. So you have to be very alert because sometimes information systems can be wrong. It was a bug. It was a bug. Maybe it was a factory bug and they just got the information in their system, which is also the same problem as the factory. So understand that when you're diagnosing cars, just question parts, be aware of your equipment, how it works, and sometimes you better have more than one gun. So if you have one scan tool, it's always nice to have another one, especially if one doesn't communicate with something and you hook up another one and it does. So just understand you need more than one gun in your shop. Now, computers are all over the car. I scanned a couple cars today where there's like 45 computers on this one Mercedes. 45 computers. So when you pull a computer out, you better know what it is. And there's a lot of questions you need to ask about that computer. You have to kind of like say, who are you? What are your needs? What exactly are your needs? And who's your players? What kind of tasks do you perform? And what are your strategies? These are the same questions I ask a chick when I meet a chick for the first time. Same questions, because I want to know all about her. See what she's all about. I want to know all about the ECM. I want to know how it works. I want to know if I did pull it out, if it is an engine computer. Because I had a tech years ago I worked with at Cadillac, and he said, oh, the computer's behind the glove box. So he pulls the glove box out. It's an 85 Sedan DeVille. And he went to the parts guy and goes, give me one of these. So he gave him one of those. He puts it in the car, and the car still had the same problem. It actually had a bad board on the ECM. So I tried to help him out. I'm like, dude, you pulled out the wrong computer. Over here is the BCM. Up here is the ECM. The BCM is pink connectors. The ECM has the blue and the red. So he pulled out the wrong computer. So you need to get your all data systems, or Mitchell, whichever you're using, and component location is very crucial. So know what computer you're working on first and make sure you have the right computer in your hand, because there's so many now. There are so many. And by the way, too, these computers now are all, the newer cars now, they're all on network. This one here is nothing. There's probably, I don't know, maybe there's 25 computers there or 30. And this is nothing. And what it is every one of these guys are joined in on a network. And all these, there's certain guys who may be friends with him, who may depend on an ECM saying the ECM and the ABS, the instrument cluster, they may all rely on this guy. So you could have a system where maybe 4 or 5 guys may complain, and your scan tool is right here. Your scan tool now joins the party. When you plug your scan tool in, and that puppy's plugged in, let's just say it's a scan tool, you have entered the party. Now you are one of the nodes on that network. So understand that if you have a problem where you can't communicate and you want to validate whether it's your tool or not, go out on the network, and let's say your tool has a list of, let's say, 10 computers you can access. Go to each one of these computers and write down codes on them, because if you have a lot of computers going, U code, can't talk to the ECM, and another one, U code, can't talk to ECM, ECM failure, then you know that they have the same problem as your tool. So you're on the right course, but how do you know that you can't talk to the computer because the whole network is down? You don't know. So validate your tool and validate who you're talking to. It's not that hard. It's very simple. But that's the way you have to do it now because of all these guys that are on board. And also understand that when you turn off a key, that a lot of these guys go to sleep at different rates. These guys may go to sleep right away. You know, the ABS computer, the trans computer, the PCM, the occupant restraint control module. So these guys are in red. By the way, this is Chrysler's, it's their scan tool, and they're the only ones out of the 20 manufacturers actually did a really phenomenal job because they really want you to diagnose cars. And they put the whole network in a spot where I can tag any one of these icons and go right to the computer and do my diagnostics on that particular computer. So they also, it's live. It's live information. So if I shut the key off, these guys are going to automatically red. Over here, if I have a code in a particular computer, they'll turn up yellow and saying, hey, we have a problem, we have an issue. And on this particular vehicle, this Grand Cherokee, these computers were all inoperative. So if you went in with your scan tool into the PCM for no start, you're like, oh, okay, the car won't start, the PCM won't talk. It's probably the PCM or wiring. But meanwhile, you didn't go and check other ones. You go, oh, look, the ABS won't talk either. Could be the ABS computer or wiring. Oh, wow, the TCM won't talk either. How are 3 computers going to be bad? So you see how this helps out by going a little further with your tool and checking other modules, because that's the way you have to do it now. You have no choice. This makes your job easier. And they're nice enough even to put, if you're online with this tool, they actually put flash files on these controllers that say, hey, there's an update for this guy if you want one. And updates are very crucial. We're going to talk about these as we go along. So the main thing is, don't be so focused on one in-op computer. You need to see whether it's more than one computer having the problem. You know, you'll actually go in and other computers can have a complaint like, look, you'll get sometimes a theft light in a car. And most cars have theft lights. Some don't. But it's nice to have it on. You turn the key on, the theft light's on. Then meanwhile, you go talk to the computer, he won't talk. But the anti-theft computer is saying, I can't talk to him, so I'm going to leave the light on. So there's another piece of information. So that's why I say go into all these modules that you can. Makes your life a lot easy. And I get a lot of calls for no communication. A lot. And the thing is, you got to decide, well, does the car run? Let's say you're talking to a particular computer, let's say the PCM. Does the car run? Well, yeah, okay, that's good. At least we know the computer is not bad and its power and ground's all right, so it could be an issue with your tool because you didn't answer the correct question, because when you set your scan tool up, you're setting it up to talk to this particular guy. If it says, hey, does the car have ABS, or does it not have ABS? It's going to ask you a lot of questions. You need to answer the right question. If you answer the wrong question, there may be a chance you won't be able to talk to him. I've been there when I had my Ford tool and I wanted to talk to an ABS computer and asked me whether the car had some kind of special system, and you had to actually look at the brake booster to see if there was a switch on there. And I think it was like whether it had a traction control system built into the ABS system. Wait, where's... IVD. Was it? IVD, whether it had IVD or not. And I just said, I was in a rush, I said no. So because I did that, I couldn't talk to the ABS computer. And I'm like, dude, the ABS light's on, the computer's in op. So here I am checking all the powers and grounds, and they're all good. I validated the communication line, it's good. So I'm like, it's gotta be the computer. So then we get a used computer, put it in, same exact problem. And I'm like this, where'd I go wrong? What did I do wrong? So now I went back into the tool again, and I saw the question, I answered it properly, now I got in. Now I'm talking to this new computer that we just bought, this used one, and now we have a code that we have to deal with. So you see how you can screw yourself? So I'm just telling you, make sure you set your tool up properly. So this car basically was running, and it failed inspection because it couldn't talk to the car, right? And let's say you hook up your Snappy scanner, you have no communication, right? And with this particular car, it had a problem with the data line. And it could have taken out a scanner if the scanner is not protected, because Snap-on did something. I'm not here to support Snap. I'm just saying that this is a good thing that they did, because they had a failure in some of their scan tools, and they actually put a message in there now because they want to check the voltage on the data line on these particular cars. And they said, over voltage on communication line, disconnect scan tool and see manual. They want you to disconnect it. They don't want you to leave it on there. And then you go, look, you know what? I haven't seen it yet, but I heard that Snap-on has some kind of new box that they made, because this is nice. Anybody have one of these? OBD II interface box? This is the best thing. I mean, I think on the back of your books, AES sells this, the TST, the booklet, not the handout, but the TST booklet. There's a company called AES. You can get these. I think they're probably like $100. And I'm going to tell you something. This tool has diagnosed a lot of cars for me just by plugging it in. When you plug this thing in, first of all, you plug it underneath the dash, and you're out here. You can actually work out here. But you want to see whether or not these two ground LEDs light up, pins 4 and 5, okay? And also here's your pin 16 for power. I mean, you hook up your scan tool and it's dead. You're like, well, what's going on? You know you probably lost power or ground. You probably most likely lost power. So now you got to take time out to find out where the power came from. You know what I do? I hook this thing up. I put a jumper lead in here. I run it to the battery positive. Boop. The box lights up. My tool now is powered up. I don't have time to diagnose why pin 16 is dead. So I'm there to diagnose the car. And also, these grounds, you better make sure both of these grounds light up. I'm going to tell you why, because certain scan tool companies can use either ground to toggle the line, the data lines. Because when you command something of the scan tool, it'll use this ground to toggle the line going back to the computer. So you can have one bad ground and your scan tool may not work. Another guy could use a different scan tool, his works, because his is using the other ground. I've already seen it. So it's just a nice quick tool. Or how about the guy goes, the car won't pass inspection because I can't communicate with it. So I go there with my tool. I used OBD II, hooked in, I communicate. I'm like, mine works. Well, mine doesn't work. So let me just extend this thing out. I'll put this thing on here just so we can both tap in real quick with this instead of going into the dash. So I went to put it in. I'm like this. As I wiggled it, the lights would come on and off. I'm like, it's got a bad connection here. So then I said, wait, let me just get a good connection. Plug his machine on. It communicates. Do you realize that the pins in that OBD II connector, the pins were slightly worn, and I guess his connector just didn't mate properly. Maybe his pins were a little thinner than mine. So it was all about a connection problem he couldn't see. So I'm just saying, little things like this help your diagnosis. And here's me validating. I go into the connector and I actually saw 12 volts on that line. And when you see 12 volts on that line, you better know when these guys are plugged in, they're pretty safe. If 12 volts gets on the line, these things have like a Zener dial built in, and they're smart enough to know, hey, if the communication line goes to 12 volts, we have a way to protect ourselves. So they'll be protected. Is your scan tool protected when he joins the party? I don't know. But what happens is, now you got to start unplug, because all these controllers get power and ground. So it's very easy for the controller to go bad and send power back out on that data line. So you have to go there and unplug every single computer that's on that network. Can you imagine 29 computers? You're like this, where should I start? Start with the most common. A radio. A lot of the radios are all computerized now. Or go with something that lays low. underneath carpets where there's moisture. Maybe the airbag took on some kind of moisture. You don't know. But you go for the most obvious things you see. And here, a guy put an aftermarket radio in that wasn't wired properly internally. And it actually put 12 volts on that data line and took everybody out. Now, when he puts the radio in, the radio works fine, the car's working fine. It's when you go to inspection and they plug in, they go, can't communicate. So that problem was there since the radio got put in. And I've seen this problem many, many times over. This wasn't the first time. Number two is your equipment. You need to start checking. Let me tell you something. If your cable's damaged, I mean, I know it's happened. Like my cable, I always put it through the window. I never put it between the door. I've had guys accidentally, like I put it through the door once, slammed the door, I'm like, oh no! So then he opens the door, and it's all squished. I'm like, oh my God. I start kissing. I hope you're better, I hope you're better. And I bring it back to where it was. But you know what? There's damage already inside. You can have one strand that's busted inside, and that one strand may not do that one car, that 1 year, make, model, module. You'll never know. That's why you need more than one gun. So if you have damage like this, or you have connectors that are all corroded, I mean, I don't know how you take care of your equipment, but you need to look at your equipment when you're hooking it up. Cables and connections. And we already talked about the connector, right? These pins have a tendency to collapse. I already had them before. They'll collapse, so you have to just get in there with a pick and just close them up a little bit. Or just make sure there's no corrosion in here. You just don't know. And like I said before, pin 4 and 5, all right, industry standard, that's going to be your grounds, and here's your battery. But what I always wanted to have three, this was my dream that I always wanted, to have 3 LEDs on each port. So you can have red if it gets to a certain threshold towards battery voltage, and green if it gets like shorted or gets close to ground, and maybe amber. And the thing is, you have to hook up the different cars that work. And understand all the way on Volkswagen, I do so many Volkswagens, these are lights that always flicker when I hook up my scan tool. I've never seen it at red before. You know what I mean? It'd be great. And I heard that Snap-on has something. I don't know, I have to look at it. But it would be really nice if someone really went the full effort, and because it's all about cost, right? Another thing too is, when you have problems with ECMs, you need to go look at it very carefully and think about, did it get contaminated? You know, when you're working on any type of computer, you need to go grab them and go inspect. Like one guy, this is very common, where the guy goes, I don't know, the transmission's not shifting right, and I have all I put in gear, and I go to drive it, and I can't talk to the computer, and I don't know what to do with it. Dude, go find out where it is and just start hooking up, like checking your powers and grounds and stuff. So here we lift up the rug, and it's in a compartment, right? And then I open up the compartment, and out pours water. Just pours out. Why would you put a computer under a carpet, knowing that if the sunroof leaks, it's going to end up on the floor? So this computer was toast. And then the guy goes to me like this, blew him out. He goes, you think we could just blow it out and reuse it? I'm like, dude, it's done. A lot of these flood cars that are coming into our shops, people are like, well, what can you do with it? Dude, it's toast. You need a whole new wiring harness, fuse panels, computers. The car is totaled. You want to drive the car? I'll fix one problem. You'll come back next week and you'll charge it again and again and again and again. There's no guarantees you can do with them. Because they actually dried the whole car out, and the stuff is still there. It's still there. You can't tell me this thing's going to survive being submerged. I can't see it. So, I mean, here's one where it got damaged by antifreeze. Well, here's a smart move. Let's put the computer under the heater core, on the hump. And then let's go one step further. Let's give it a nice little plastic flap. We'll put a flap on it. Hopefully no one will remove that flap. They've got to put it back, because when it does leak, the flap protects it. That's just the way it is. So if you do come across a flap or a design, put it back on. It's for protection. But antifreeze will kill it, and we talked about it, so will moisture. Being visual. Once you see this, it's history. You're not going to clean it up. Another thing too is, be also concerned not with water entry, or let's say liquid entry of any kind, whatever it may be. I've had gas. I had one that got filled with gas. I'm like, how does gas get in a computer? This is on a Vortec motor, a GM job. I'm like this. And even all the connectors were swelled up like this. Oh, like that. They weren't even like elliptical. They were just like, they looked like a figure eight. I said, dude, that smells like gas. 5 cents Diagnostics. I said, that smells like gas. No, it can't be. I'm telling you, it smells like gas. Do you know that the injector housing, the seals were leaking in this housing where they have all the injectors, and actually the fuel pumped through the harness, the injector harness, and filled the ECM. I was like this. I was mesmerized. So when you get a failure of liquid, you got to find out how it got there. You better, because you just can't put it back in. You can't, especially if you have a water drain problem. So understand that smelling is good. It's a good thing. They call it the old sniff test. Jerry does sniff testing. All right, so listen. Another thing too is, speaking of sniff test, you ever get in a car and you go, whew, that smells bad. Something is burnt to this car. You just did half the diagnosis. Car coming in, won't start. And you know what that electrical smell is all about. But here's the problem. You got to say to yourself, I open up the board and this thing is burnt beyond recognition. All right? Where is it? See this chip here? Wait on. That's an IC chip. I remember years ago I was sent to GM school for like a week in Terrytown. And I'm here to tell you the manual was like this thick. They made us learn about everything on the circuit board because they knew where the industry was going. I had to learn about resistors, transistors, xenodiodes, IC chips. We didn't repair the boards, but we literally learned about all parts because they want us to be involved in the electronic world because we were working on cars that were getting high tech, and that was back in 1985. And I'm telling you, I know this is an IC chip, and this thing controls, it's a driver circuit. So you got to say to yourself, something burnt it out. Because if you put one of these in, it's a very expensive fuse. Very expensive. So you have to go in there and start checking devices the computer is going to ground, driver circuits. You have to take a list and find out whether it's injector drivers, not coil drivers. You're not going to sit there and ground a coil and check how much current it is. But injector drivers, solenoid drivers, relay drivers, and just make sure nothing is where it should be, where it's low enough to create high current, because that's what took it out. And on this Nissan, it's very common for the IAC motors. They short all the time. I had one I couldn't figure out. I'm going to give Richie Shorts credit for it. I thought I checked all the wiring. I thought I did. And this guy said to me, he put another one in. Oh no, he hired me. He says, look, the old one was burnt. And I went there just to program a new computer. Because, I didn't know. He said maybe someone started the car backwards. So he put the used one in there. I was going to get ready to program it, because that's when this came there, not for a diagnosis. Also, I'm like, dude, smoke. So we just pulled out real quick. And I'm like, wow. So I said, let me just check all your wiring. I checked all the wiring. I couldn't find out what it was. It was on a Nissan. So Richie went out there, and he checked everything over. He found something I missed, I overlooked. He found electronic motor mounts circuit was shorted. I'm like, dude, electronic motor mounts, where did the hell those come around? It's just something I didn't know about in that particular car. And apparently Nissan is having a problem with electronic motor mounts, and they just disconnect the motor mounts and leave them disconnected and put new computers in them. So it's something I overlooked, but it took out the used ECM he bought. It was just one pin I didn't probably check. And thank you, Rich. Good man. We talk about powers and grounds. So when you get any computer, the best place to check any powers and grounds of the computer is at the computer. Because I'm going to tell you, there's no guarantees that if you check a fuse out here, that power is ever getting to the computer. There's no guarantees. I've seen many failures of fuse circuits where wires can be severed from corrosion. They're just sitting there in a happy place. When you go find it, you go like this. What's that green stuff? Bink. It's amazing to me. So the best way to check any computer is to check Battery feed, that's its source to keep it alive. Ignition feed, that's what wakes it up because it's already alive, right? It's sleeping just like you with your alarm clock, right? You're sleeping at night and your alarm clock wakes you up. That's the ignition switch. That gets you going. Grounds. You need to check all the grounds, not just one ground. A lot of these computers have 6, 7, 8 grounds, 10 grounds, and we get lazy and go, well, I checked the grounds. Well, what'd you check? I checked this one and that one. Did you check them all? No. Each ground has a job. I'm here to tell you. How would you like to go work on a GM car with no pulse? It was an early version car, and it all happened after a guy hung a starter. He hung a starter, put the starter up, now the car won't start, no injector pulse. I'm like, dude, did you do anything? Did you cross the battery or something? And he goes, no, there's no more pulse. And back then, you could take the purple white wire with a test light and the positive side battery. You're not going to hurt nothing. You could do a scratch test. You go, tit, 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 no injector pulse with the key on. And meanwhile, you can communicate to it. I'm talking to the computer. I'm like, dude, what's your problem? What are your needs? What are your needs? So I'm like, TPS is not at wide open throttle. You have RPM signal, because I already checked it with a scope. And so what are your needs? So I went in there, and I thought I checked all the powers and grounds. I thought. I neglected to check 2 grounds. One of those grounds was for the injector driver. See, the injector driver needs a good ground, and it's going to take the injector circuit power through the injector to the computer, right to ground, and ground the injector. That ground was broke. So when the guy pulled down the starter, there was an eyelet with 3 grounds. There was a brown wire and 2 black wires. One of the black wires pulled and broke, but the other 2 held on for their dear life. They go, oh my God, dude, you're hanging the starter. He hung it because the harness all pulled. He broke 1 strand. That's all it was. So meanwhile, I said, let's try an ECM because I thought I checked everything. I got burned on it. So since that day, I check every single ground feed there is. Ignition feed, battery feed. So this is no mystery here. Ignition, and there's 2 more feeds that come into play now with the new cars. 2 more feeds I want you to be aware of. Do you know a lot of the driver circuits now, where we thought they used to be ground controlled? They ground it. Now the solenoid circuit is grounded, and now they send power out. Imagine that. They'll send power out. How'd you like to have a solenoid code on a transmission? And the guy checks the wire from the transmission computer back to the trans, and then he sends his own power, and he can energize the solenoid. So he goes, computer's no good. He puts a computer in, same thing, solenoid codes on the trans. Do you know that Honda, for instance, has a dedicated fuse that says solenoid? It feeds the computer power so that it can feed, it feeds the computer power, right? So that the computer can take this feed and ground the injectors. How nice is that? A blown fuse. A blown fuse for an ECM. So understand that you got to check all your power feeds. Same thing goes with the throttle bodies now. These electronic throttle bodies. How do you think the computer, when you get high current circuits that any computer is going to control, where do you think it gets this power and ground? It's got to send power and ground out, right? Sometimes they'll put a dedicated fuse feeding the computer to feed the driver because it's power and ground fed. So the guy replaces the throttle body, replaces the computer. Meanwhile, it's a blown fuse. Blown fuse. Already been there. So these are new things now. Driver feed fuses. Something to think about. And then when you're setting up, let's face it. This Ford has 60 pins. This is nothing. 60 pins to check. I can tell you from memory that 20, 40, and 60 is ground, and 47 and 37 is power, and pin 1 is usually battery. I just know from memory. But now you get all these wires, you're like, oh my God. So don't get overwhelmed. What you got to do is get a diagram, go in, and you're going to have to do this. How many guys use highlighters? It's not a kid thing. It helps you out. What it does is it takes that whole ECM wiring harness diagram and it actually hones into where you want to work, right? So all you're going to do is look. Find your grounds, right? Label the grounds green. I use green because the grass is green. So that's my ground. I'll use green. Highlight all your grounds. We have 1, 2, 3, 4 grounds here. Highlight your battery feed. Now I use orange You can use red, but GM for the longest time used orange for battery feed. So I used orange, right? And in the ignition feed, they've always used pink for ignition for many years. So I used ignition feed coming in here from a relay. So here's ignition feed, battery feed, ground, 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 and ground. Now if you wanted to, you could also highlight the crank sensor and cam sensor. I use yellow for any type of sensors. And I use blue for driver circuits. But look at this. Now that I know where all these wires are, I pull them out of the hat. I just put a piece of paper there just to show you, look, now with all these other wires laying around, I'm going to check battery feed, which I had. Just with a test light. I'm not going to get too anal and start checking the crank and cam sensor for what? It's a no start condition, no spark. Isn't it easier to take a test light and you better know where you're putting this thing? Because if you're checking powers and grounds, you're okay. You take a test light from the positive side of the battery and you go like this. Is that a reference voltage or is that a ground? Big pop, it's done. Reference voltage, reference power will not tolerate high current. LED test light. How many guys use these? Power probe. So it turns green. Green means good, right? Good ground. And red means good power, you think? Do you know how many amps those little LEDs pull? They probably pull about 20 milliamps, 30 milliamps if it's lucky. So that's 0.03 of an amp. That's nothing. I'd rather use this to check powers and grounds because this is about 300 milliamps, 0.3 amps. So I can load the ECM like this. Yep, good, good, good. Just statically, just to check it, rather than this, because this could burn you. If you're using to check powers and grounds, it could burn you. So I use this. I'm from the old school. I like to see a bulb light up. I've seen guys who actually made a headlight. They take a headlight and they load it. There's actually companies now that make load test lights. Someone in the class the other night was talking about it's a load test light. But I went in there and checked. Power here had power. Went over here, no power. All it was a bad relay. That's all it was. A bad relay. There was no ignition feed going to that ECM. That's all it was. But yet, you see right here? Oh, let me just take the zoom out. You see right here? What's laying over there? ECM. This guy tried an ECM. But it's so easy once you pull these wires out to check ground, 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 power, power, you're done. So just simplify the job. Just simplify it by pulling out the wires that you just want to check. And checking fuses too. When you're going to check a fuse panel, you know, there's always voids, right? There's always voids. Now, what are the voids for? Why do fuse panels have voids? We always see it all the time. Fuse panels always have voids. Yeah, there can be options. They're not even used on the car. But the problem is, what if a dude had a blown fuse and he thought this was the bank? And he goes, I don't have a 10 amp fuse, but I'll borrow it. I'll put it back later. So then he takes the fuse out and puts it where it's got to go, and he doesn't realize that he could be creating another problem if he doesn't put it back in. He has no idea what that could be for. Meanwhile, he pulls a fuse out on a Nissan Sentra. That's the crank fuse. That's another power feed to ECM. Anyone know what a crank fuse is used for? Crank fuse. You crank the car, power's going to go through that fuse to this guy and say, hey, I'm cranking the car. And what happens is this. This is interesting. Here's normal. All right? Normal run. Let's say, don't look at this section, but normal running the car. You see how the injectors fire? Let's say 1, 3, 4, 2. 1, 3, 4, 2. That's sequential firing. That's sequential firing of the injector. Okay? See what that is? That's called group firing. You're going to get 4 times the amount of fuel when you crank the engine. See, I'm cranking the engine here. Once the engine stops cranking and the car runs, it goes back to this. If the fuse is missing, it does that all the time. It will never do this. So now you put the fuse in and the car's fixed. But meanwhile, the customer didn't complain in the summertime. They complained as the colder months came into play. Well, you know, I don't know, my car's hard to start now. But she doesn't remember that the car was just serviced like 3-4 months ago in warm weather. So you have to watch out that when you're checking for fuses, there may be spots that are void because someone removed the fuse from that spot. So you say, well, I checked all the fuses. Yeah, you checked all the fuses over there. Well, the ones that aren't there. That's why it's always nice to go get a wiring diagram and find out where the fuse is in the panel. That takes care of your problem. And also, too, on scan tools, they have that PID. When you crank the engine, you'll see a PID that says crank yes, crank no. It's there. And when we're checking fuses to these computers, all right? I've got burned many, many times. When you check a fuse across the top, is there any guarantees that fuse is good underneath?
No.
I've had many, many situations. Many. I got burned last week, 2 weeks ago, on a GM car that wouldn't start. And I was checking to see why. I checked the fuse, it was good, and there was no power getting out to the ECM. So now I'm spending all my time going through the horns on the outside of the engine compartment. Meanwhile, the whole problem was someone put an aftermarket device. They put like one of those, it's like a U-clip. They shoved it in there, put a fuse in there, and at one point in time, they took it out and threw it out and put the fuse back in, but they didn't fix the collapsed pin. So at times, it would start, it wouldn't start. So I got there, the car wouldn't start. And all was because someone had
Spread that terminal.
spread the terminal. And by you checking across the fuse, you know, especially if it's hooked into the power side, you're checking the fuse is good, so you're going to go elsewhere. So always validate when you take the fuse out. And you know what? I remember years ago, what the heck was that? Was that a Volvo? They had these fuses that were in the panel, and you had to take them out and put them on emery cloth just to clean both ends, and then clean out where it got tension, and the tension would lose on the fuse. So you had to go there, clean, emery cloth it out, then you had to push the fuse holder back together and slop it back in. Fuses were big problems. So connections with fuses is a big problem that we overlook all the time. I want to ask another question here. Anybody hear of transport mode? What the heck is that? Transport mode. It's a mode of a computer, especially ECM. Transport mode. It may affect other computers too. How do we get the cars across the water? Put them on a ship. Now what happens when they're on a ship, over time, that long journey, some batteries could go dead or low enough. So what they do is, certain manufacturers like Land Rover, BMW, Volkswagen, they'll go into the car and they command the vehicle to go into transport mode. So it has limitations, a lot of things. The radio won't work, maybe. The AC won't work. The sunroof may not work. Certain features of the car may not work. The car has reduced power, right? And you don't know. But they're supposed to take it out of transport mode. The dude at the dock, the guy who works all the cars coming in, the prepper, he has to prep the cars. One of his job is take it out of transport mode. Now, how do you like this? How would you like a car to do this? Defaults to transport mode. One of my customers, it was pretty good. He did some digging, because now you got to do digging. It used to be you had a manual where you can go all down to Mitchell and you just go the normal route, the regular route. But stuff happens to cars that are different. So he accessed Identifix, which is nice, good information, IATN. Now he's networking. So, has anyone seen this? I have a Land Rover here, and I don't know. The sunroof won't work, this won't work, that won't work. One guy goes, you're in transport mode. What? So when he goes in with his scan tool, he doesn't have the feature to even check it. All he has is codes, data, some functionalities. He says, John, I think this car's in transport mode. I know you have a Land Rover tool. Really? Transport mode? I never had a call for one. So I went there, I look, sure enough, it's in transport mode. So I hit a button, he says, would you like to take it out of transport mode? Sure. Boop, done. Job was done. Unbelievable. What they're doing now in some of the cars, they have this. Transport mode. Little sign. They're nice now. Transport mode. Full engine power not available. Drive momentarily. Have the system checked by the nearest BMW dealership. How about Autotech on Wheels? Or how about Joe's Amico or something? So they want these cars to go back to BMW. But that's what they're putting on their cars if it's stuck in transport mode for their own safety. So when batteries go low, a lot of things can happen. So if you have multiple things going on, it's not a bad idea to go do some soul search on the internet. You can Google anything now. I'm not kidding you. Google anything you want. You'd be surprised what comes up. You know, you should have like a Google station right there on your desk. Hold on, man. What's your problem? Okay, no problem. We'll get Joey on it. You know what I'm talking about. The research is real good. And here's the other thing too. When you have blown fuses and maybe you don't know what's going on with that blown fuse, you put it in and it's not blown anymore, there's a reason why it did blow. So you need to find out what feeds that circuit. You have to find out all the players involved in that circuit. You don't just put a fuse in. Hopefully, I mean, if you want, put a fuse in and the car works, send the customer and say, look, I'm not going to charge you nothing, so you're not liable, and let's see what happens over the course of the next couple days. It may blow, it may not blow. But intermittent shorts are a hard thing. So you at least want to take time out, and maybe if you look at the diagram, you go, all right, well, it feeds the oxygen sensor, and it feeds the idle speed motor. That just feeds a bunch of components. You go, you know what? I don't know. The oxygen sensor is close to the exhaust manifold. Chances are maybe it laid and burned on the exhaust, which it can. So just use a little reasoning to try to figure out who's the most culprit. Who could be the most culprit? Now look at this here, right? EGR tubes, common, where things will melt against them. ARR pump tubes, same thing, the air pump, the hot tube that goes into it. Here, exhaust manifold, right at the back of the engine here, right? Look at this guy, this EGR sensor, EGR solenoid harness, got melted on the exhaust here. How about a van with a doghouse where the harness lost its conduit? Or maybe it cut through the conduit, and look, it's chafed right here on this red wire. So that when the owner goes, you know, it all happened after I accelerated and put in reverse. He just gave you valuable information. Because when you put a car in reverse or drive, you're torquing the engine either way, so you're also moving harnesses. So if you were to put a fuse in and the customer said that, because you need to interrogate your customers, because a lot of times they're going to give you the answers you want. I'm here to tell you. The answers are there if you really know how to interrogate your customer. But just beware of fuses. You put them in, and just beware what blew that fuse. Another thing too. Now here's a good one. I went to a shop, and I said to the guy, well, the relay's bad. He goes, dude, don't worry about it. Do I have relays for you? He brought out I'm here to tell you, this basket, and emptied it. He goes, find the one you want. I'm like, oh my God, dude. How long have you been collecting these? Oh, for years. So he's going to just try to match one up that looks like the one that I need so that this guy can work efficiently. This module needs a nice relay to work, the wake-up call. They don't always use ignition switch with a fuse. Most manufacturers like to use relays to wake up any type of computer. And the highest failure of computers going in op can be relays. I've seen it because, you know, the contacts pit. Do you know that Nissan took their 2005 Pathfinder? Yeah, I think it's a Pathfinder. I had like 4 or 5 already. They put their ignition coil feed and the ECM feed on the same relay circuit. So now, who's the bigger guy that gets the pie? The coils, right? They like to draw, so they're sharing the same contacts as ECM. So the guy goes, I don't know. I go to start the car, it almost starts and it dies out. And I'm like, well, let me see what's going on. So I get over there, hook up my scan tool, and I'm just looking at stuff. I was looking at cranking RPM. And when I cranked it, it attempted to start and died, and my scanner lost communication at the same time. I went, that's weird. My scanner just lost communication at the same time as the car almost wanted to start and didn't start. So what happened was the PCM lost power from the relay because when the coils went to fire, they drew down the circuit and drew the power away from the ECM. I knew right there, I said, you know what? I lost power or ground. Let's go to ECM. And that scan tool directed me to the problem. Even though his problem was hard starting, like it would want to start, and then it wouldn't start, the scan tool helped me out. I lost communication while I was cranking. These relays are not always the same as they appear. The thing too is, if they got water damage, you're never going to know until you open them up like that. Look at that puppy. That thing's water damaged. So you don't know where these relays have been. Do they come out of flood cars? I don't know. But used relays are nice, but you have to watch out. You know, industry standard on a relay, you know, if you look at the relay, it's going to have 30 and 87. Those are your two contacts like this. They're always opposed. Here's 30, here's 87, right? Then you have the other two guys on each side, 85 and 86. Those are the relay coils. These guys are the contacts, right? So all we're going to do basically here is ground. We provide power to the relay, and it has a ground, and it latches. What's this guy here? This little guy here. Look, diode. Do you know a cheap relay may not have a diode? So you put a cheap relay in a computer that's going to ground the relay, and once it grounds it, you know, the grounding part is easy. It's the letting go. Once the computer driver lets go of that relay, it's kind of like a bully in the yard. You knock him down, you go, ha ha. He's like, dude, when you take your foot off me, you're dead. You're mine. He'll spike you like there's no tomorrow. And that's what's going to happen to the computer. You could damage a computer with the wrong relay. I've already done it on a blower, an AC power module on a Cadillac, where I repaired the connectors. When I first started working for Cadillac, I didn't know. I saw the dial, I'm like, whatever. And I just repaired the wire, put on the clutch, and the car was working, click, 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 poof, stopped clicking. And what happened was, it spiked the controller that was controlling the AC compressor. That was bad. I didn't know that back then, back in '85, about these dials, how important they were. So just be careful with with cheap relays. And you ever see these guys? You ever see on a relay it says 8787, doesn't say 87A? Like it'll have 85 and 86 here, and it has 87 and 87A, but this one has 8787. Is there a difference? Look, this is double gang. So when you energize the relay, it's going to feed two things at once. So when you pull this relay out, if you pull this type of relay out, and it's an 8787, you put this relay in there, the car may not start. On some of the BMWs, they use 8787. So you really need to watch out for these type of relays. When you take a relay out, get the same exact relay put back in. I'm here to tell you on that. And you know, grounds too. I mean, you know, the best way, if you have one of these power probes, these are pretty cool, because you're already hooked to the positive and negative side of the battery, and there's a meter on here. You can literally go to any ground you want, any ground, and crank the engine and make sure it's no more than 0.3 cranking, 0.1 running, because that's the rule. When you start to crank any engine, if you were to test a ground, engineering spec would be no more than 0.5 cranking on the first initial spike. And this you'll never ever see with a meter, because a voltmeter takes an average. How many guys have a graphing meter? Some kind of graphing meter. Vantage, there's a lot of them running around. But that's the best thing, because you're looking at voltage over time. And a voltmeter doesn't adjust it because it takes an average. Let's just say you had a bad regulator on an ECM. It could go from, let's say, 6 volts to 4 volts and fluctuate like this. Meanwhile, you're only seeing 5 volts. You don't know. By looking at it over time and graphing it, you get a better visual of it. So here's me cranking the engine, jumps to 0.5, then it just stays under 0.3, continuous, just stays there. So checking grounds, put your negative side of your meter on the battery positive, battery negative, and just start checking all your grounds cranking. So if you're at this ECM, you're going to check the grounds, very simple, and do not unplug this module. Don't unplug modules when you're testing wires. Why is that? You don't unplug them. You want to check them, load it. Don't ever unplug wires. Don't go like this, unplug them like this. Oh yeah, oh yeah. You want to check it plugged in. Check your grounds and crank the engine. I like to crank the engine as I'm checking everything. I'll crank the engine, check the battery feed. Crank the engine, check the ignition feed, and see the ignition feed stays there. How would you like to have a bad ignition switch, which burned me? Where I turned the key on, I had power. Cranked it, I lost power. Bad ignition switch. That one burned me. I said, oh, it must be the module, because you turn the key on, you have power, you have ground. Let's change the module. Wasn't the module. It was a bad ignition switch. So after that episode, I always check power and ground while I'm cranking. And looking at grounds, you know, you get a ground, it may be tight, but not necessarily clean. We always think like a tight connection is good. It's the clean connection. You ever see those star washers? I see them all the time. Guys will take things apart and go, what's this star washer for? Hey, Joey, catch. So let's see how far it can go. They don't put them back. That star washer has to bite the surface. Especially if a freshly painted vehicle, and you just put the cable on, there'll be no connection. I've had situations where, you know, the guy put the cable on, it made no connection. He's like, he took his test light from the positive, from the negative side of the battery, and he went, no, wait. Yeah, negative side of the battery, and he's touching the engine. Oh my God, the engine's short the power. Look, it's light up test light. I'm like, dude, it's looking for a ground. You're giving it a path. So you need to understand to check your connections and make sure they're clean, not just tight. And this can happen with grounds for computers, usually like ECM grounds. They put them on the engine. They like to put them on the engine most of the time. But the problem is, where do they put them on the engine? Right? How about putting it over here on the thermostat housing? And the guy goes, I know Hondas. And I cleaned the ground. I took it out. I cleaned it real good. I cleaned it where it mounts. I tightened the bolt. I still don't have I still have a no start situation. He goes, I changed the computer, still won't start. Changed the distributor, still won't start, because he knew all the failure patterns. But you know what? I took a test light and touched right here in the thermostat housing. It was dim. I touched on the engine. It was bright. How's that possible? Thermostat housing.
Corrosion between the two?
Corrosion between the two. That's all it was. Coolant corrosion between the two. And why they would ever put it on a thermostat housing is beyond me. I just took it off, put it on the engine, and the car started up. Just by looking at reference voltage. You see, when you have a running problem or no start problem, and it's very simple just to turn the key on and just check the reference power, because that's the heartbeat of the computer. So computers, when you get powers and grounds in, they have to send reference power and reference ground out. So if you simply put a voltmeter, and you know, well, I know the TPS gets 5 volts, and you put your voltmeter on here, and it's at 7 volts. Imagine I'm 5 volts. Now I'm reading 7 volts. Am I 7 volts, or am I actually 5 volts? I'm 2 volts off of ground. So whenever you see a reading that's too high, it's elevated ground. It's a ground problem. If you see a reading too low, it's a power feed problem. Just a little tip for you guys, because I go over here and I see 7 volts for my 5 volt reference. You see it? 7 volts? Look at my grounds. They're 2 volts. So you can actually take this power probe, and you're on the battery, and you can touch, don't do this, but you can touch the reference ground and go, 2 volts, something wrong there. So what's happening is the electrons can't go from the battery to the computer, then from the computer to the sensor. So by you doing this, you're allowing the electrons to flow through your device to that sensor. See, electrons will take the path of least resistance. Just like you have a bridge down the road and it starts to back up, you build your own bridge here. And you're like, you guys want to come on my bridge? There's no one on it right now. Depends on how many guys come on there. If you get, I don't know, 0.1, you're okay. 0.2, 0.3, 0.4, 0.5, you don't have to look at the other bridge. You know the other bridge is backing up, depending on where your meter, how your meter reading is. So voltage drops are not that hard. You're just taking your power probe, you're right on the negative side of the battery, and you just go in and just touching grounds. No more than 0.1. It's as simple as that. And you can literally just unplug a coolant sensor and check for 5 volts and a good ground, just to validate that the ECM is functioning properly, or if it's alive. If you have no 5 volts, it's dead. Computer's not alive.
John, when you're using a power probe to do a voltage drop, you're not connecting both leads on the battery?
Well, I mean, you can leave both leads on there, but it's the ground one, because the thing is, you have to power this up to see the meter. So you leave them both on there just to power up to see the meter, and then you're looking you're just checking the ground to see what the level is. And it's a quick check. You can go anywhere and check the ground with this, anywhere. But good question. And here's our 5-volt references, because we talk about the computer gets power and grounds in. It's got to send 5 volts out to independent sensors, has to send a good clean ground to all your sensors, and then there's a shareware 5 volts. This guy here, where he shares more than one sensor, let's say a TPS, a MAP, a coolant sensor, that dude there, if he shorts to ground, hibernation time. The computers will actually go to sleep. They go, I'm out of here. You're stepping on my heart. I don't like the pain. I'm out of here. And until you leave that short, this computer will not come alive. Chrysler has that problem with their crank sensors. I mean, how convenient is it? Look, 3-wire sensor, 5-volt reference, and you have your reference ground. They can come together like this. Boop. And that computer will go to sleep. So you have to literally go like this. Or I checked, John said check all the powers and grounds. They're all good. Now check your 5-volt reference. It's 0. And the computer's dead. So now you say to yourself, is the regulator bad inside here? Or is it something shorting on the outside? You don't know, lack of voltage could be a short, or it could be an open circuit in here because the regulator is no longer good. Nothing's coming out. I mean, if you wanted to, you can cut the wire to the computer and go, hey, look, I got the 5 volts back. But you take the first step of unplugging all the extremities. Every guy that's on that line, that 5-volt line, you want to unplug. And like I said, Chrysler is the most common for shorted crank sensors. You go in, the computer has no communication. I've seen many guys replace computers on them. And I'll go this, and like the 5-volt reference is dead. So I'll go out and I start unplugging stuff. I unplug the crank sensor, comes back alive. So checking the 5-volt reference is very crucial. You know, here's an indication. Look, here's a coolant level sensor in a GM car. 3-wire sensor. Has the 5 volts in there. The coolant went bad, seeped into the sensor and go, hey, 5 volts, hey, ground, you guys want to dance around a while? Okay, stuck his nose in there. And now they're shorted, like this. And guess what? It affects anything on that 5-volt line. It'll pull down, because anything that gets 5 volts, it can either shut down the car or make everything go lower than it should be. Look, the 5 volts on this was at 2.65 volts. Didn't get full 5 volts. The car didn't run very good. And all you had to do was unplug the sensor, and everything was corrected. Now, you could have said, well, the regulator is probably bad. The regulator is at 2.65 volts. It's a bad ECM. The regulator is no good. So you put an ECM in it, still at 2.65 volts. So maybe you want to do this. You know, if you wanted to, you can cut the wire, and because maybe it's partially shorted somewhere. It could be touching the block somewhere. Seen that? So if you want, before you spend big money, just cut the wire. What's it going to cost you for a little bit of solder? Put it back together. But you can't just cut one 5-volt. Because here's the thing. The 5-volt regulator could move out the different pins. It can go this way. There could be 3 5-volt lines coming out of here. One could be bad, and it could take the other 2 out over here. So then you got to cut all 3 5-volt references. Already seen it happen. How would you like to have 10 Chryslers in a row, and every one of them was a bad crank sensor, right? Now you get that one that fed 5 volts into the transmission on this Chrysler. The problem was in the trans. As the first one I had, I'm like, oh my God. I cut the wire going to the trans, and the car starts up. I'm like this. Didn't see that one coming. So it's not just one 5-volt line. You got to check them all. This is just a 5-volt regulator. Bias voltage is a good diagnostic tool. How do you think we get codes that say circuit high, circuit open or shorted? Wheel speed sensor open or shorted. Now, a wheel speed sensor produces its own AC voltage. You know, it's a magnetic sensor that goes, hey, how you doing? AC on both lines, right? How does the computer know it's open? What computers do, they do an integrity check. They will send a minute amount of voltage, and we don't know what it's going to be. It could be 4 volts. It could be 7 volts. It'll send voltage down one line and a ground down the other. So let's just do a little math. Let's say it sends 5 volts. So plugged in, it's 2.5. Shorted, it's 0. Open, it's 5. So the computer is monitoring that line all the time. Or just maybe on one key startup. You do a key startup, it does what I call it touchy, feely. That's what it is. And it may do it for the first couple seconds. You ever see an airbag light go like this? 1, 2, 3, 4, 5. What do you think it's doing? It's saying hello to you? Hey, how you doing, Joe? Nice to see you get in the car today. It's going through an integrity check. That's what it's doing. So what's nice about the bias voltage is, if I wanted to on a wheel speed sensor, I have to wait. I need someone to start the car up because it could be there momentarily or it could be there all the time. I just go like this. I go on one side of the car. I go, all right, so open circuit wheel speed sensor. I go like this. I put my meter across there, 2.5 volts. Oh, is that good or bad? I don't know. So I got the other guy on the other side going, pick me, because he should have the same reading. So he's the donor. So he's the good side, so I want to learn from the good side. Go to the other side, unplug the wire, I check the bias voltage on the wire, and it's 2.5. I now know that it's nothing to do with the wiring, it has to be the sensor. I know it. Now if I don't have the voltage on there, I know it's a broken wire. I followed all the way back to the controller. Let's say an ABS controller, had tons of them on Bosch 5 systems. I go right to the controller, I have a ground, I have no 5 volts. No voltage here. I check the other 3, so I have it. Meanwhile, the computer's saying, open circuit left rear sensor. It ain't an open circuit here. The open circuit is inside the ECM. I proved it 100% because I know about bias voltage. I know the circuit's broken inside ECM. He actually needed an ABS controller. So how do you condemn an ABS controller that keeps telling you the problem's outside? It's not outside, it's inside. Remember, the circuit's just not out here where the wire goes out and it comes back. The circuit is in here too. So when you get a code, this is part of your circuit. Understand that. And we know about comprehensive monitors. In OBD II systems, just like any other computer, comprehensive means it's the touchy, feely. It's going to check any component that's unplugged on the vehicle. And the best way to do it is 3 key startups. Because you could probably clear the code and start and go, oh, it didn't come back. Yes. Just had to clear it. Now you wait a minute, start again, light comes on. Because it was a 2-trip check. It could be a 3-trip check. I'm just telling you that if you get a code where it's open, short, if it says open or short, high or low circuit, it'll say circuit high, circuit low, or circuit open, circuit shorted, right? You want to start the car up 3 times in a row, because after the 3rd time, if it passes, you're okay. And computers do not know the difference between open and shorted. It's the same. It's a lack of voltage. Because, in a driver's circuit, you get 12 volts, goes through the circuit to a device, comes back to the computer, and the circuit's high. When it grounds it, the circuit's low. If the circuit's already low, it doesn't know whether or not the circuit's open or someone beat it to the chase and grounded it before it did. Maybe a wire touching, because I already had one on a Ford to kick my butt. It had like 2 driver codes. Meanwhile, the whole harness melted into a hot tube on the engine, on a van. It's like a 2002 van or something. The whole harness actually fried on top of this tube, and it took out a couple driver circuits. Driver circuit low. It's just amazing to me. Here's one. How many guys do inspections? All right. You ever see the comprehensive monitor and the fuel system monitor say not complete? How can that be? I can clear the code on any car, and I just clear the code, and they're complete right away. I didn't even start the car. Keys on. Right? I go like this. Boop. Complete. All 3 of them. Every single time. So a guy says to me, hey, this computer, we've driven the car about 1,000 miles and it still says not complete. Still, how can that be? It can't be. It has to run it all the time. So I'm looking at this thing, I'm like, it's pretty expensive to replace this thing. That was on a BMW. So what would you do? Would you put another computer in it? What would you do? What? Well, you know what? I took a chance on something. I says, maybe if we reprogram it, it'll go away. I don't know. I don't know whether it's hardware or software. I don't know. I just know the problem is here. It's got to be. It's got to be. But I'm like, that's a very expensive computer. I'm like, let's take a shot at it. There's a software update. I put it in. Get done. It's complete. I'm like, oh my God. So I'm thinking, what this is? I decide I'm going to coin this phrase. Automotive menopause. Has to be. This guy was working for like 80,000 miles, and all of a sudden, something happened inside, and he said, I'm not going to check those guys anymore. I'm done. That's it. So it must be that. Because how is it a computer stops its function? It's unimaginable to me that a computer stops its function. So I went the extra mile. I'm like, I had this gut feeling that maybe if I program it, it may fix it. And it did. It fixed the car.
Did one on the GM for me.
Yes, dude. It's amazing.
Yeah.
And you're in like denial, and you're like, it's worth a shot. It either works or it won't work. But just something to think about that these boxes, there's always update software for all kinds of boxes, all kinds. I mean, there's 40 computers on board these cars. There's always going to be software updates. It's not just one guy tells you, hey, you want to do, pass-through, we're going to program ECMs. It's not about just programming ECMs anymore. It's programming everything on the car that has a program available for it. We're going to talk about just a couple main sensors. We're going to get too crazy. Just the main ones you're going to see on all types of computers. Thermistors are one of them. And one thing about a thermistor, you have two wires. 5 volts and ground. It doesn't get no more high-tech than that. And we're just putting a resistor across it that when temperature reacts with this resistor, it has a negative coefficient. So it takes the 5 volts and ground and goes like this. Come on, a little more. So it starts at like, let's say 4 volts. It has to have change. Computers have to see change over time, right? I mean, look at Obama. He says, it's all about change. He's right. It's all about change. Got a lot of change in my pocket now. But this is about change. Computers have to see change. And if they don't, they actually look at the coolant sensor. If it takes too long to change, do you realize it won't run a lot of OBD II monitors? Because it says it took too long. It won't even tell you that. I happen to look at some monitors on a Toyota, because when you go to OBD II monitors, it actually has an extra monitor for thermostat. I'm like, thermostat? So they put that in there themselves. They're checking the thermostat and see whether or not it passes, because they're looking to see how long it takes for the car to heat up. So you can have suspended monitors that'll never run because of a bad thermostat, and you have no code for it. So these guys have to work. And another thing too is, look, you see this guy here, this coolant sensor? Car's overheating. Fans just don't come on. Car overheats. What's that? Corrosion. So the coolant came up to the sensor and caused contamination, corrosion. So what happens with corrosion? What does corrosion do? Resistance. So now the engine is hot, but the fan is never coming on because computers have lookup charts. They're told to do is like, when you reach 190, let's say 212, put the fan on, okay? Okay. But if it never sees it, it's never going to do it. So you need to get a little smart. Look at your scan tool and look at the temp and just validate all your PIDs. That's the bottom line. You got to validate anything you see on the scan tool. You'll know. I mean, take it a step further. How many guys have temp guns? I mean, you're not going to go like this going, ow, that's really hot. That's like 212. Come on. Or put your hand on the hose. Wow, I can't keep my hand on it no more. Days are gone. You need to get smart and just buy equipment that's going to make your job faster. These things are good, really great, really great. I may even step up and get one of those infrared guns. They can look up temperature, all different areas. I'll give you like a map, like blue, yellow, red. They probably have them for automotive, they're a little cheap. And here's another thing you guys should know about is you hook up a generic scan tool and you get negative 40 on the coolant sensor, right? Hook up a factory on the factory side, the forward side of your scan tool, not the generic side, and I get 46 degrees Fahrenheit. Why is that?
Substitute value.
Substitute value. You better watch out for that. OBD II generic can't substitute values. So if you have a code that says coolant sensor high input, look, if it sees 5 volts, that's high. That's an open circuit. It's high. Either it lost the ground or it's broke. Something's broke. So if you put your voltmeter on that wire, the reference voltage, it'll be 5 volts. So you go, well, it's either the resistor's not there anymore, or the ground is bad, or the connector's open. You already know about the 5 volts. It's all about that 5 volts. So, and look what the scan tool has, an extra pin. Coolant sensor, 5 volts. So they'll usually give you, if it actually substitutes a value, it'll give you a second PID, voltage PID. That's when you know it can substitute a value. So understand about substituted values. Don't be fooled by them. This is just what they're doing. They're taking an EGR valve and they're putting a thermistor in the valve and looking for change. So it's not always that a thermistor is in liquid. It could be in air, to check air. They use them in air conditioning systems, in ducts. They use them all over the place. Their job is to check the change in temperature. So if you get an EGR code that says there's an EGR fault, you can't just check the EGR solenoid to see if it's sending vacuum to the EGR valve, to see if the diaphragm is pulling, and then you have to go there with a tool and suck down the valve to see if there's change. The computer checks for change, temperature change. You think it's going to have temperature change with that? What's that? CRUD, clogged passage. So don't be too honed in on thinking that a code is all about electrical and mechanical. It can also be about air, fluids. That is another part of your diagnosis. You need to know how the system works. If you don't know how it works, how are you going to test it? So just understand that. I want you to understand it. To take your mind a little further than the book to know what happens in the real world. That's like the guy who had a stuck thermostat and the coolant sensor was, the fan switch was actually in the radiator, so the coolant really never flowed to hit the sensor to turn the fan on. And he goes, the car's overheating, the fan don't want to come on. Dude, maybe it's the thermostat. You're playing around with the cooling fan and the coolant switch. You're getting too high tech. Keep it low tech. I went down here and felt the hole. I'm like, dude, it's cold down here. He forgot about the old stuff. So that's what I'm saying. Simplify it. Don't get too high tech. The other ones are potentiometers. So we talk about thermistors, potentiometers. When I was a kid working on cars, I used to go to the back window and I'd put my ground somewhere like this on the grid, the heated grid in the back, the defogger grid. I go, wow, it's bright. Oh, it's getting dimmer and dimmer and dimmer and dimmer. Oh, it's out. That was the early design of a TPS. It's a potentiometer in one respect because you became a potentiometer. Here's your 12 volts, here's your ground, here's your resistance, and you are the potentiometer. You're the TPS. That's all this thing does. So if you lose your ground, it'll always be high. So you need to make sure, and you need to know the levels of these potentiometers. Because when you look at molding doors and air conditioning systems, anything that moves from point A to point, it's all about movement. Computers check movement. So you have to know the low end and the high end and where it should be when it's commanded. So, a TPS should be like around I'm thinking 1 volt or half a volt at idle. Then wide open throttle should be close to 5 volts, but never 5 volts and never 0. Because that's an open or short circuit. And understand that they'll have problems with these resistors. They will have problems with these resistors. And sometimes problem with the ground. So always unplug and validate your 5 volts and your ground and check here. But understand when you check here, there is no guarantee it gets there because it's 3-wire. See, a 2-wire, you're guaranteed. It's a straight run. You have 5 volts in ground. 3-wire, you're guaranteed 5 volts in ground, but there's no guarantee that this guy is ever making it to ECM. So if you take a reading here, it's, let's say, 2 volts, and you go to ECM, it's 0 volts, you have an open circuit. So just validate a 3-wire sensor. When you validate it here, and your scanner reads something different, just make sure you go here, just to make sure that it is getting it, and maybe not be something internal. And you guys know about clear flood? It's a mode of a computer. Computers have different modes. And clear flood is something that's been around for a long time. I mean, you do something like on the Fords, I can do a crank and compression test. I can hold my foot all the way down the floor to keep the injectors from working. Some manufacturers have it and some don't. But just keep in mind, what if you had a bad TPS that was stuck, that had a bad reference ground going to it, and just to a point where it was bad enough to falsify wide open throttle. Now you lose injector pulse, no start. So just keep your mind open about different modes, strategies of ECMs. So you may have, in fact, a possible problem where the potentiometer could be stuck in one spot. You know, computers will command, let's say, an AC door to open with the motor, and the motor's trying to work it, and the motoring door is getting stuck, and it'll actually hold back on the current because saying, I don't see movement, so I'm going to pull away that driver and stop moving that particular door, and then it'll set a code. So the sensor is watching the activity of the motor. Or what if the sensor's not working, and you hear the motor working, and you see the door moving? So you need to understand how these sensors work. Another thing too is, you know, you're going to see a lot more of dual sensor setups, and it's for backup, especially when you get into electronic throttle body. You know, you go, oh my God, what's this thing on the floor? APP. APP, what is that all about? Accelerator pedal sensor, right? You have 6 wires. Now, what does a TPS have? How many wires? Potentiometer? 3. So if it has 6, there's probably 2 in there. So could you tell me by looking at this, which ones are the 5-volt reference? You see the 2 twisted sisters? Which ones would be the 5-volt reference? What? Which one? Maybe these 2? Why is the wire twisted? Interference. So who do you want to protect? The signal. So what do you use to protect them? Ground. So they took the reference ground and wrapped around the TPS line. I know these 2 wires are 5 volts. Why are we using a diagram? But that's pretty cool that you use your visual. And you know, I know it's 6 wires. I know the 2 wires have to have 5 volts. 2 wires have to be ground, and the 2 wires have to have change. So you put your meter on there and just check for changes. You move it. That's how you test it. You don't just condemn it right away, saying, oh, I have a hesitation. Well, just check it. So it's not, once you understand how potentiometers work, it's not really hard to check it. It really isn't. So we have potentiometers and we have thermistors. And connections. You're going to see connectors have a lot of problems. They can break right here. The wires can be weak right at the connector. Very, very common. And guys overlook it. Want to know why? Because they're taped up so well, they're all held together. Meanwhile, take the tape off and do a little wiggle and pull, wiggle and pull. They'll go boop, boop. Guess what? That's what your problem is. Intermittent. You know, I've seen guys change the whole throttle body. Meanwhile, it has a break here. They may check the wire from here, because the tape's in the way. They'll check it from here back to the computer. Go, well, the wire's good. Then they put a computer in it, or they put a throttle body in it. Meanwhile, they never check the integrity of the connector here, or even here, collapsed pins. Just be aware of that. Another thing, too, is we talked earlier about bad parts. Here's an aftermarket map sensor, and here's the factory map sensor. Do we see anything different here? Just look real close. What are these pins? What are they all about? They're like barrel pins, right? They have tension on them. So when they go into a cavity, they can grab real nice. Well, a company made solid pins. So when they put in there, it went like this. Hey, ho, hey. So as a guy's driving, he's getting map codes. It's just the part they made. It's not a really good part. So when you buy aftermarket parts, you don't know what you're going to get. It's not always in the same spec. You know, they're in it to make money, and if there's a failure, you are now the person who's going to tell them what the failures are. Then if they come back too many, they say, well, you got to fix this. We got to fix it now. So just understand about parts. When they're cheaper, you know, just be very careful with them. Pressure sensors, they're found all over the place. You know, pressure sensors are going to measure either air or liquid. Whatever it's going to be. They're used in transmission systems. They're used in air conditioning, checking Freon. And they're also used in intake manifolds, checking pressure and checking vacuum. But you have to watch out that don't be so honed in on checking the wiring of it. You need to understand how it works. I mean, if you get a code for low Freon, maybe it is low Freon. There is no pressure in there. Or it could be the sensor falsifying low Freon. You got to determine what it is. Put a gauge on it. And you know, here, this thing will flex. The internal circuitry will flex. Depending, it's a piezo-resistive device that changes its resistance when pressure hits it. So it could be up here, close to 4.5, down here, close to a half a volt. So it's constantly changing on pressure. So you had a feed line, right? a typical feed line going to a map sensor, all right? And static, there's no pressure in that line, no type of pressure in that line. So basically, it's going to be a static reading of, let's say 4.8 volts, right? Then if you run the car, it's got to change, right? All about change. And if you wanted to graph it, you wanted to graph any pressure sensor, sometimes if you pull up a pit of a pressure sensor, put it in graphing mode to see how it reacts. Because, you know, it's a visual thing. That's where you learn stuff, right? So if I go to snap a throttle, just give you an example. I snap a throttle, almost swap a throttle. Look at this map sensor going, whoa, it's taking too long. Let me tell you something. When you open the door and you yell, fire, everybody rushes out of here real quick. Because the room filled, now you got to let it out. It's the same thing with wind up a throttle. Wind up a throttle, they all leave, right? If they leave too slow, there's a problem. I'm thinking maybe the door is not fully open, right? You see this? What's that? Let me zoom in a little bit. I got the zoom action going on here. Melted. That map line was right over the intake, and underneath was the exhaust manifold, and the donut was leaking, so all the heat was coming up. And syringed it to a point where it couldn't move the air volume out quick enough. A simple line. And you couldn't see it. There's no way you could see that because the failure, it was on top, it was underneath. So you're looking up top going, you don't know. But I'm just telling you that you need to make sure you check the feed to these sensors, these pressure sensors. Check the feed to these sensors because they work on liquid or air pressure. And here it is fixed. Look, wiper throttle, look how quick it shot up to 5 volts. It all emptied out because now it can get out. So again, don't be honed on the electric part. Computers will look at the speed of operation of things. If it sees a map going slow, it reacts by giving the fuel slow. Because it has, for every action, there's a reaction. So the inputs determine on how it's going to output stuff. So we're just strictly working on inputs now. We worked on the feeds of how it powers up and sends power and grounds out to sensors. Now the sensors have to determine where everything is so the computer can make decisions. And this is nothing high tech. This is them putting a map sensor on an EGR system. They want to check for, back pressure on the exhaust system so they know how the EGR valve is working properly, right? But this dude's going, oh my God, dude, a map sensor, you got it good, man. There's some hot stuff down here, right? And then look what happens. You get one of these. Oh my God. So maybe it was just exposed too much. And maybe this car didn't start because you know what happened? The 5 volts in the ground did this. And the car wouldn't start. And all it was a melted back pressure sensor, EGR back pressure sensor melted. And I ask you this. Fix the sensor, fix the wiring, put it back. We done?
No.
Why? Why, Ed?
You gotta fix the original problem.
What caused that to melt down?
Exactly, maybe a clogged exhaust system.
I feel the love. I feel the love. I feel the love. Good move. Good move. You see, so when things fail, you better find out why they fail, because they're going to fail again. I'm here to tell you. It's so simple to replace stuff. Find out why that part failed. Another sensor too. We'll bring up another sensor. It's a mass airflow sensor. It's a sensor that has to measure air volume. So they want to know about air volume. So we measure pressure, we measure temperature, we measure movement. How about not so much movement of a shaft, but how about movement of air? And this is something that they want to check as well, the movement of air. So this is done, we'll just take a mass airflow sensor with a little hot wire, and the hot wire sits in the bore and does this. Okay, come at me. So the air comes in, the rush of air will cool down the wire. The job of that sensor is to maintain the temperature on that wire. So as more air rushes in and cooled off faster, it's got to put in more current to maintain. So it looks at the rush of air and it can determine how fast the air is coming in. The only thing is, you have to watch out for pirate air. Pirate air is a very common problem when you have ducts that break. I just think, thank you God, that Saab is out of business now. Oh my God. Oh, they're rough cars. They were very rough for me for many, many years.
Saab is out of business?
Yeah, dude.
Wow.
Yeah, dude. But they're gone. Feel bad. Try and get support on buying software and stuff. It's rough now. I don't know where you go. They sold the company and lasted for a little bit, and they just gave it up. But yeah, they're gone now. And also, you know, I went to get gas the other night, and I says to the guy, I'm over here at Exxon. Dude, what kind of truck is that? Label came off. Why? He goes, this is the last truck in the state. He goes, I'm losing my job. I've been driving Exxon trucks for 20, 30 years. I'm losing my job in March. I'm like, what? He goes, yep, all Exxons. They're all going to be privately owned, either by the owner, they're going to be franchised out. Exxon is saying, we don't want to get involved in no more gas stations. We don't want the gas, we don't want the ground, we want the tanks. We're done as of March.
Really?
As of March. The dude told me he's out of business in March. He's gone. So either if you're owner of an Exxon station, you have the option to buy it, or he told me the distributor buys it, who brings the fuel from Exxon. Exxon just sells the gas, says, thank you, leave, but take the sticker off my truck. You can have the truck. I don't even want the truck anymore. Yeah, it's going down in March. I just got word out the other night. So we got over here, oh, I'm sorry, a little leak over here. So just be aware that the sensor has to measure. And look, and the guy replaced the sensor with a junkyard sensor. And he never even looked. This bothers me. He never even looked at this duct and inspected the duct. I mean, he bought an expensive watch, right? That was good. But he ain't coming to train to spending money to come to training. He'd rather buy a watch. Like, dude, you need to be a little more sensitive and look at stuff. Be visual. When he lifted up, I'm like, oh. I saw it. I was visual. That's why my first slide was about being visual. Found that by being visual. It was unimaginable.
What is that, a crack in
A crack in the duct. I guess just from the movement of the engine, it was just a bad design, but you won't see design no more, so that's a good thing. So, and then fuel trim. This is my own theory with the fuel trim. This is like layman's terms, okay? I'm gonna make it real easy for you guys, because a lot of guys say, what is fuel trim? How is it all about? Dude, imagine I'm Longy, and my dog is Shorty, right? So I take him for a walk. He's walking in front of me. I stay here at 0, right? So my dog is walking, bing, bing, bing. He can only go to like maybe 35%. And then what he's going to do is pull me. Because he's saying, I'm looking at the O2, and I'm seeing it lean. I got to add more fuel. He pulls me again. It's where I end up, is where the fuel's going to be. Because what's going to happen is, he'll see the fuel going rich. Now what he's going to do is, he'll kick back. He may lift his leg and try to pee on me, and I'm going to jump back a little bit. So now I'm back at, instead of at 8%, I went back to 5. Now he's happy. He's pacing back and forth, waiting for the next move, just pacing over here. He's the short term. He's always moving. He's pacing, but it's where I end up, is where the fuel trim's going to be. Now, fuel trim, understand what fuel trim is. You have fuel trim at different aspects. You have fuel trim at idle. You have fuel trim at part throttle, 3/4 throttle. You need to find out where your problem is going to be. So if your fuel trims are high at idle, power brake the engine. If the trims start to come down, you know it's a vacuum leak. Or it could be maybe a mass airflow that's out of range on a low end. I don't see too much of it. Usually mass airflows fail at a high range. So now, let's say your trims are perfect at idle, and you go to power brake it, then your trims start to climb. I can tell you now, it's going to be either low fuel pressure, clogged injectors, or a sensor giving wrong information. Because what's happening is, it's happening under load, not at idle. And you really need to check for vacuum leaks, and don't forget about the PCV valve. See, computers have to look at the sensor, and their whole job is to control the O2, keep it switching. Because now this guy is the main feedback to keep closed loop operation working properly. It has to maintain the switching. It can't be high all the time. It can't be low all the time. So its goal is to keep it switching, but it depends where it ends up. You end up beyond 15% long term, you're going to put a check engine light on. There's just no two ways about it. So you got to find out what the problem is going to be. And here's your contamination, right? Here's a nice clean one. Here's a real dirty one over time, and they can be cleaned. And here's what I call the Don King syndrome, right? You see that guy right there? That's some guys buying cheap air filters, that fragment. Oh, I don't want to buy that filter. It's $35 and it's impregnated with oil. All right, dude, buy the cheap one for like $5, $6. Go ahead, knock yourself out. You don't want to do that when we have mass airflow systems. And the last one, this is a special one. I call this one the seed of destiny, because some mechanic, you ever see them little things you make a wish, you like this? I wish you can go nail mass airflow and hang tough on the hot wire and bring me a customer. That's what happened there. Can you imagine that thing hung on a mass airflow wire and create a problem?
Can't see it.
Oh, here, oh, wait, here, I'll bring it in. Look, there's a little seed. See it? I'll see if I can zoom in a little bit more. You see it? The little wish? How did I get in there? It's amazing to me. And it hung on a hot wire and caused the problem. What's the chance of that happening? Being visual. Pull that out. I didn't know what to do. I was going to just take it out and make another wish, and hopefully it'll make more money. All right, so we closed loop timer, basically closed loop operation, another mode of a control module. It has to see O2 activity, has to see proper operating temperature. So once it reaches temperature, it goes into closed loop and starts looking at O2. Then it starts adjusting things. You shut the car off, it can be fully warmed, start back up. It doesn't go back to the closed loop right away. There's a closed loop timer. And understand that if you start getting trimming problems, like when you start up a car first thing, it's an open loop. If it's running real lean, then it warms up, it's running good, the computer's adding fuel and compensating for a problem. Because cars are built and designed to run good cold. If they're not running good cold, let's say they're running a little lean, you're not getting enough fuel. If it runs better hot, it's actually adding fuel to compensate for it, because now it's in closed loop. So understand that. And here's another scenario. Car runs great cold, runs perfect cold. But once it warms up, I got all kinds of O2 codes going nuts. And meanwhile, you find out the O2 sensors were crossed. I've had many of those where the car runs great when it's cold. As soon as it goes to closed loop, that's a problem. Dude, you better be looking at O2s because it's a closed loop operation problem. So just use your mind a little bit. And when you speak to people about problems, your customers, find out when the problem occurs. It can help you out. O2 sensor, we already spoke about it. Basically, they can come one wire or two wire. If it's one wire, it has its own dedicated ground. They used to do that years ago. So the ground was usually on the engine. And basically what it is, you screw the O2 in the exhaust manifold. Some guys used to put that anti-seize compound on it because it had a graphite in it, and it actually provided a better ground. Because you screw a sensor into a rusted hole, it didn't make a good ground because it has to go through the exhaust manifold to the block where the exhaust manifold is usually rusted up. And then from there, they'll tag another wire on the engine, and that wire hopefully makes it back to ECM. It's kind of like you having a voltmeter. You go like this. You tag the O2 with the red lead. You tag the engine with the black lead. It's the same scenario. That's how the computer sees the O2. This wire breaks. It says, hey, O2 open circuit. It doesn't know what to do. It can't see it. It's like you taking your meter off. So these are bad designs. Very bad, bad, bad. So those are gone. So now it's all two wires. But I'm here to tell you, a two wire is not a two wire. And a four wire is not always a four wire. They're different types. You can get yourself in a lot of trouble if you buy the wrong sensor and they're not to spec. I'll give you an example. The old one, the ones that were around, and they're still around, what happens is the casing of the sensor is grounded. The O2 sensor is grounded to the casing. So the computer goes into the sensor and grabs its ground off the case to take a reading, right? Then it'll lock itself right into the sensor to take a reading. So it's going like this, okay? Taking a reading. This guy here, he's isolated from ground. I ran two independent wires right to the computer, and the computer actually grounds this wire itself and monitors the O2. Now, can you imagine having this type here, this type sensor here, where you swap these two over? You'll have an open circuit because this one is isolated, right? So if you were to put, let's say you had this guy here, and the computer's relying on this ground, and you put this guy in there, you have an open circuit because there is no O2 ground. Because this computer's looking for a ground, and this guy doesn't have a ground. So when you buy a two-wire sensor or a four-wire sensor, you can have a problem where that sensor may be wrong for the car. I already run into it. So just be careful when you're buying sensors. Make sure they're good quality sensors and the application is correct.
You meant before when you could have sensors switched?
No, what happens is a lot of times the O2 sensor connectors are very close to one another. And I've seen it on Mercedes, I've seen it also on BMW where the connector's so close, when the guys work on the motor, they go, where'd it go back? And they plug the sensors into the wrong place. So now you have cross-bank, where this guy's on this side, this guy's on this side, and he swapped them over. And your trims actually go opposite. So one side's totally negative 25, the other side's totally positive 25. That's how you nail it. Your trims go opposite each other. That's how you nail them. So we talked about O2 sensors. Another thing too is switch status. You know, it's very easy for any computer just to hang a voltage line and just wait for someone to pull on it to zero. That's its command. It's no simpler than that. And you take a typical AC system where the AC switch is. Sometimes when you push that switch in on the control head, all right, it grounds a wire that comes from the computer. So if I were to unplug the harness at the AC switch, I look for the reference voltage. That's something you don't want to test with a test light. I already had a guy actually blew the circuit out. He actually damaged the ECM. Took a test light, I don't know what he was checking, but he was checking it and then he took it out. But basically what it is you're going to get a reference voltage line coming into the car, right at the switch, and all the switches do is this, just ground the wire. I had a bad AC control head. The guy ripped the whole car apart. I don't think he was looking for. But I just went to the AC control head. I identified the wire. I ground it. Clutch came on. It was that simple. If it doesn't come on, you have to find its route. Because what will happen is you'll go from the AC switch. It can go through a high pressure switch, through a low pressure switch. It can go through an evaporator switch. You don't know before it gets back to the ECM. And these switches just create gates for the wire. So all it is one wire, and it goes from the ECM to any controller out to multiple circuits before it gets to the end of the rope. So if you wanted to, you could literally go to let's say a pressure switch, unplug it, check for voltage here, all right, and then your ground is coming from the other way. I can literally check for voltage, I can ground it here. If it comes on, I just keep backtracking the other direction. So these switches are fed low current voltage. Be very careful. So when you're checking any type of pressure switches on the engine, know these pressure switches, any kind of switch is going to have some type of reference voltage on one side. You start taking a test light and you probe the test light for the power side battery, you will damage the ECM. So switches are only for high and low transition. There's nothing complex about it. Just so you're aware of that. That's another type of sensor in one respect. A one-wire independent sensor that just has one direction, up and down, or down. RPM sensors have been around for a very long time. Even back in the old days of pickup coils with GM distributors, or pickup coil, electronic ignition came into effect in probably, I don't know, what was it, the early 70s? God. Yeah, when did it come in exactly? 75, yeah. So, I mean, when points went away, I'm like, oh my God, what's this all about? We gotta go to school. Oh my God. It's just pickup coils. They just introduced pickup coils because you had a shaft. They have to determine shaft rotation. That's what all about. It's all about the shaft. How it rotates, how fast it rotates. So what they need is a sensor to determine the shaft rotation. Because computers are looking at a lot of shaft, whether it be a drive shaft on a wheel speed, or whether it be a crankshaft, a camshaft. They're all being checked by some type of rotational sensor. Most common is the AC magnetic sensor. And here's what you have to understand. You have a shaft which has to pass with a unique design in whatever is attached to the shaft, pass a magnetic core that they wrap around a field coil. So what affects the output of the AC voltage coming out of these two ends is going to be the resistance of the coil, which you can always measure back in the old days. Pickup coils should measure, I don't know, 700, 1200 ohms. We used to measure them out. Just make sure they're not deteriorated, because you can have a weak AC output. Also, how strong the magnet is. Also, the gap is the main thing too, the air gap. So if you have well, we're going to go over that. But the air gap, the speed of the shaft, the strength of the magnet, and the field coil. If it's a 2-wire magnetic sensor, you can actually go in and do an ohm check on it and measure resistance, providing you set your scale properly. And here's the other thing too, little clue. All right, we're going to look over here. We're going to test this sensor, but it does not work. So before we condemn it, what's wrong here?
I couldn't crank it.
Not turning. Shaft must turn. I'm here to, I was burned by it many times, because I would check stuff and put my meter in, and you're not looking to see if the rotor's actually turning. My God. You're checking on the outside, you're checking your output. Is the distributor actually turning? So just make sure the component is turning. And again, the air gap is very unique, and whatever wheel triggers in front of the sensor has a unique signature to it. It creates a unique signature, the way they make the wheel. So each wheel is designed for a specific year, make, model, engine. The wheel determines what the pattern's going to look like. And here's another thing too is, we put in a sensor, a typical sensor. We'll put it in place. Okay? Brand new sensor. I test the sensor. It don't work. It's brand new. It's got 3 wires. 5 volts ground, and it's got reference power, reference ground, and reference voltage. The voltage line has to be toggled to ground. I put my meter on it, nothing's happened to it. What do we notice right here? You see this right here? It's not down all the way. The dude stuck it in the hole and did not push it down all the way. So when you place a sensor and you see an elongation on it, when you put any sensor in place, it has to be fully mounted, properly in place. Especially if you're putting a sensor on a spindle where it's going to measure the rotation of the axle trigger wheel. Make sure it sits flush. If there's any rust in there, don't clamp down on a bolt and have it on an angle like this. You have to have a 1/16 of an inch, that's all you need. 1/16 of an inch can have an effect on the output of that sensor. I kid you not. 1/16 of an inch. And here's another thing, just to show you. You see how small this pattern is? All I did was fix the air gap. I brought the sensor closer to where it had to go, and look at this. Now the computer sees it. Now understand about computers. Computers don't really understand AC voltage. They never did. The voltage signal has to go into an AC to DC converter. They understand DC. They don't understand AC. So internally, the computer has to take the AC signal and digitize it, and then it looks at the square wave of the signal internally. It gets digitized. It's AC to DC converter. But the problem is this. If the signal goes below a certain threshold, usually 0.7 volts, it doesn't see it. It goes into the inverter and it goes, I don't see it. So once it gets to a certain point, it's no longer seen. You can see with your scope, it's just too weak. I've had cars years ago where the car would run at, let's say, 1,000 RPMs, and all of a sudden you let it go below 700, boom, it stalls. Guy goes, I don't know, I got to crank the idle up and hold the idle up at 1,000 RPMs to keep the car running all the time. If it goes below 700, it stalls. All it was a bad pickup coil. That's all it was. He thought he had an idle problem. He's put an idle speed motor in. He's cranking up the idle. I'm here to tell you that weak output, computers can't see it. So understand about these thresholds. And here's another thing. On the end of this crank sensor, this piece of paper, is this packaging? Is it something you peel off and you put on your forehead to change your religion? What is it for?
That's the air gap. That's the air gap.
You don't peel that off. You need to leave that on there, hammer that sensor all the way in, because here's the clue, the elongated hole. Sensors that mount with just a regular hole, they're fixed. They go in one spot and that's it. But if they're elongated, you need to push it as close as you can to that shaft that's moving. and then the paper, once you do that, you tighten it down, the paper gets ripped off. That's how they maintain a gap that they want. It's a gap that they want, a certain gap. And it can't be too small, and it can't be too large. Has to be just right. We'll talk about just right, and how just right gets bad. How would you like to have, it's a BMW, runs perfect. Perfect running car. And if, as I accelerate, it goes, whoa, 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 whoa. Car wouldn't go nowhere. It ran great, but when I got to a certain RPM threshold, it would not run right. And I have you know that the Bernie Master actually helped me with this one. He said, dude, how's your crank sensor look? It looks good to me. Well, what's your amplitude on the crank sensor? I don't know, I'll go back and look at it. Oh, about 137 volts. He goes, 137 volts? That thing's going to rev limit. Because computers don't like high voltage. And some of the older computers couldn't clip AC. AC can just be runaway. So there's a certain threshold that has to be. If it gets beyond that threshold, it creates problems. Without a scope, you would never, ever find this problem. And all it was the air gap was too close. It might have been a sensor he bought that was aftermarket. Might have been a little longer. You bolt it down, and that's where it's going to be. So what I end up doing to this car was I had to shim it back. And when I shimmed it back, we'll go over this way, to the left. Look at the result I have now, 70 volts. It's just something that happens. I always thought that, let's get closer, because close is good. And further away, nothing happens. I never knew that too close is no good. I never knew. I had no idea. So I think that in some of the newer cars, they clip the AC voltage. Some of the older cars, they couldn't clip it. You know, I guess they didn't think it could happen. But just something to think about. If you're checking an AC signal, too much is no good of AC signal. I hear someone laugh in the back there. Also, when you're looking at signals, you need to look at the integrity of that signal, how well that signal is being made. And sometimes you can have a problem where let's say you have an ABS problem where the car is slowing down, and you may get like a right, like a lockup. Computers only do what they're told. They look at sensors and make decisions. So if they see something erratic with the signal, they could see it as something slowing down on one wheel. It thinks the wheel's locking up, so they can go with the ABS apply and not necessarily ever set a code, because to it, it's something that's normal to itself, that it's taken care of. Computers will set codes for ABS systems when it sees an open circuit or a sensor not working at all. But if you have a sensor that's working erratic, you're never going to know without a scope. How many guys have scopes here? I'm just curious. Scopes. That's phenomenal. So looking at a pattern, I'm not saying being anal, but just look for something that's different. So if something is different that catches your eye, like, I'm looking at this going, what the heck is that? And then I'm looking over here going, wow, if I count the teeth here, let's say this, I don't know, let's just say there's 35 from here to here. There's about 36 teeth on that tongue ring. I'll bet you there must be a bad tooth, because it comes back repetitively in the same spot every time. I'm just using logics, just by looking at it and just seeing what the problem could be. Now meanwhile, we find a problem and it's a chipped tooth. How does a tooth chip? How? I had a guy one time that was, I don't know, he was using some big pry bar to move the engine, you know, because I guess he was doing a timing belt. He actually clipped one of the teeth on the trigger wheel behind the crank gear. I'm like, dude, use the big bar and you're turning the motor. I don't know what you're grabbing, but you pop the tooth off and the car just didn't run right. Didn't set no codes, just didn't run right, and that's what I found. I was checking just like this. And I said, something doesn't something doesn't look right. It just doesn't look right. There's one spot in there that doesn't look right. And then when I went a little deeper in, that's what I saw. He broke the tooth off, just doing a time belt job. I don't know, just trying to turn the motor. And trigger wheels are so crucial. I mean, it's one thing having the sensor, because the computer only knows the wiring and the sensor. That's all it knows. And the sensor has to read whatever the trigger wheel is going to give it. So each one has a signature to it, right? But your vision is very, very important. because it's a mechanical thing moving. So it's up to you guys to take a deep look to see what's going on. Now, you see over here, this trigger wheel on this axle, and you see the location of the crank sensor? What's wrong over here?
Not centered, right?
I don't know what it was, but you know what happens with a lot of these axles? These things can crack, and they can move. Or worse yet, how would you like to have an axle company send you an axle, and the trigger wheel is correct with the teeth, but it's too shallow. The teeth are shallow. So when you replace axles, or how about this one? You buy an axle, they didn't put the ring on it at all. There's no ring. Oh, you didn't order it with a ring. Or you didn't tell me it was ABS. These are questions you need to ask. Well, does it have ABS or does it not have ABS? So when you order up any type of axle, make sure you check this ring for it's shallow, how shallow it is, how many teeth it has, and was it pressed on center? Because anybody can just throw it in. I've seen it time and time again. So just be careful with these things. Here's one. Let's talk about being visual. I always tell my girlfriend, guys are visual and women are just all about sensitivity. We like to look at stuff. What do you see there? You see that? That could really screw you up because you're getting a really erratic pattern. And without and even on the scanner, hopefully, I mean, you don't always see this on a scan tool. You may not. It may not always be guaranteed because it can get so intense at low speed that the scanner may not show it, but a scope will always show it. And you have to compare. I saw one time one guy, he's working on the car, and he's got a scope, and he's spinning the wheel, and he's checking that side. Then he goes the other side. He's spinning the wheel, checking that side. I'm like, dude, what are you doing? Well, I'm checking the output of the sensor. Against what? You're not comparing side to side. So I mean, are you spinning that tire faster than the other side? I mean, I don't know. I don't know what he's doing. So the whole idea is when you're trying to compare, doing ABS sensors, you got to compare side to side, not front to back. It's going to be different. Always compare side to side. You need to see if something's bad, you have to compare it to something else. So I'm just telling you that that's the way you have to get these guys. Another thing too is, here's another one, another situation. This is a crank pulley. Actually, I think it's a BMW. What's going on with that? Is the trigger wheel off on that thing? What's the trigger wheel attached to? Crank pulley. There's someone with that crank pulley. So you have to watch out. You have to look at whatever that trigger wheel is attached to. It's not just a trigger wheel being pressed on a shaft. It's also what is it attached to that can have a problem too. You can run out on an axle too. So it's not just the trigger wheel, it's what it's attached to.
John, what about a car where they put the donut on the car, right? The wheel size is different than the other three. What about that?
Oh, dude, I got burned on that. Do you know, I was so anal looking at wheel speed, checking the resistance of the sensor, the air gaps. So I said to my friend, dude, let me know what you think about it. He goes, John, did you know that the front tires are different than the rear tires? I'm like, no way, dude. He goes, oh, way. I never even checked the tires. Never once did I check the tires. I mean, how often you come across that? But someone put the wrong size tires in the front, in the back, and created a problem. And it was on a Cadillac. I'll never forget, it was on a Cadillac. And if you ran the car, it got to the point where the ABS system was telling the ECM to shut down the car. You couldn't drive it. It was electronic throttle. I couldn't drive the car anymore, and I got this traction light flashing. I'm like, what do I do? It's only when you go to race, when you go to take off real fast. It's slow speed was fine. So I jumped on and pushed it. It went into like ABS traction control reduction of speed. I just couldn't believe it. But yes, very good point. Something I overlooked. No one is perfect, but then you never forget it. So that's part of my protocol now too. I look at tires now. Whew. Something so simple. Keep it simple, right? And here's another thing about sensors and polarity. You have to watch out went not so much on a wheel speed sensor, but on sensors that produce a unique pattern for AC, because you can have a sensor making a down pattern. The guy gets a simple car coming in a Ford with a sensor connector was damaged, and he goes and puts another one on a Ford. Same connector. Right now, I put these connectors side by side. This connector here in this 1 year make model Ford, the wire is blue. The other side is gray. Right? His was gray on this side, blue on the other. So when he put blue to blue, gray to gray, he actually reversed the sensor. The sensor signal should have been ramping up, not ramping down. So the computer's going like this, going, when should I start? I'm not going to start my job until you tell me. You're still not telling me. So if you don't tell your worker to go to work, he's not going to work. He'll hang out and say, I'm not going to go to work until you tell me. So if you don't tell this guy to go to work, he's not going to go to work. So it's not just like, well, I have no spark, and I check my RPM signal, and it seems to work. I have a pattern. I have battery, ignition, ground. I have RPM signal in, but I have nothing coming out. Well, you need to check the integrity of the signal, not just the amplitude, not just the frequency, but the unique pattern to it. And the only way you're going to do that, well, I usually tap into all the time. I go into IATN. You know, I pay like $30 a month, I think it is, and I tap into their whole database of waveform patterns. And I look at them, I compare them. That's where you find these puppies. And another type is a Hall effect crank sensor, where they use a Hall switch, and all they do is run a trigger wheel, like a blade. They'll run a blade through it. That's all, like here. Here's the Hall sensor, and you just run a blade through it. It's no rocket science. They've used them for many, many, many years. But the problem with Hall sensors is that you can have situations where if they're not centered right, they'll get damaged. Or how about this one? The crank pulley walks out, and see how it walked out of the sensor assembly? So the whole idea is it has to be properly seated in the area, because you don't want these two components to see each other. So the blade goes through there. When it goes through it, it's usually high. You know, I remember that? Because the blade's going, hi, how you doing? And leaves, hi. So I know when the blade is through there, the signal's high. When it's not, it's low. Isn't that pretty cool? And I remember it for many, many years. Right, and we have another guy. This one's even more interesting. More interesting. It's all about the assembly of a vehicle after you fix it. All right? This guy didn't understand of how things work. You see this? You see the crank pulley? You see the trigger wheel? The sensor is up here. He had the sensor upside down. It can mount this way or this way. So trigger wheel's here. It should be mounted this way. He mounted this way. He didn't understand this has to go through the middle, not underneath. And I had a car not even last week. Go with your first feel. Guy hires me. Poop, pop, pop. I'm like, dude, this thing's out of time. It ain't out of time. Dude, it's out of time. I'm telling you, my first feel. Pressure comes out of the hole where air is supposed to go this way. It's coming this way. That's out of time. It's farting in the intake. There's something. It's firing at the wrong time. So the problem is, I made him take the whole front cover off, and I checked his belt. It was on the money. I'm like, I don't know, dude. Something just ain't right here. So I looked a little closer, and do you know, you see this little V spot right here on the trigger wheel? It was over here. And what happened was the gear and this stupid plate had two little nipples on it, and it was supposed to engage into the gear. Well, you say, well, John, what about the keyway? The keyway only goes this far. The plate can go past the keyway, and now the plate can just spin. So why even have the keyway there? You know, for the guy, you should put a long keyway and hold both on the keyway. They didn't do that. So you push the gear all the way back, and what held this plate to the gear was two little nipples. The nipples kind of sheared, and it moved on him. So he's finishing the job. He never placed the trigger where it was supposed to be. I knew it was timing. It wasn't a problem with the belt. It was a problem with the trigger wheel. So trigger wheels can move. So, but go with first feel. I went with my first feel. And he could have deviated me. I said, no, I'm going to go with what I know and what I feel. Yes. I think a Mitsubishi. I think it was a Mitsubishi. It was a Chrysler Mitsubishi product. But just something to think about. And also, these are used too, where you put the cam sensor sits in the housing, and there's a rotating magnet. This is a bad design. These magnets used to fall all the time off the cam gear, or guys used to leave them off. I'm like, dude, it's a Hall effect sensor. It's got to see a magnet go in front of it like this. And you know how you could test them? You ever see Snap-on sells those 10-pound magnets? I mean, they can hold some heavy stuff. That's what I use to test Hall effect sensors. I go like this. I put my scope on just the line, because the Hall effect, all it does is you have power, reference ground, reference voltage. It's got to take this line and toggle it to ground. So all I did was put my scope over here and watch it go up and down as I wave my magnet, up and down, up and down. So I knew the sensor was good. It was looking for this action. And I looked in the hole and it was missing. It fell off. When you know how something works, you know what to look for. And that's the key thing. And here, the other thing too is, guys are like, well, I see a square wave, it must be working. Dude, you need to look a little deeper. One thing about a square wave is different than a sine wave. Square waves have to reach a certain threshold. And the key number is 10%. So that if it's running from 0 to 5, let's say, it can never go below 4.5 or never went high. The transition has to be low to high. Computers don't understand zeros and ones, low to high. So it has to go at least 4.6 and higher, and it has to go 0.5 and lower. If it's at 0.6, it never went low. So you need to look at transition. So look, we're looking at transition. Look where this guy went. He's at 2.25 volts. He never went to ground. The sensor had a problem. It could also be a weak ground to the sensor, right? Because the sensor could be elevated because the ground is elevated. So if you had a weak ground, that's why it's always good to pull the connector off and check the reference power and the reference ground and reference voltage, 3 wires. You need to check that and look to see what its output is. And go, oh, I have good frequency. Frequency is how many of these guys show up in a second. Let's say there's 10 of them. And you look, oh, we have good frequency. Yeah, we have good frequency. Oh, we have a square wave, but what kind of square wave do you have? Is it nice? Is it reaching its threshold? So just hone in on that too. And the last RPM sensor that they have that was out there, and it's still around, it's an optical sensor. I hate them. Bad design. I mean, you have these infrared light emitting diodes that go like this. They emit light, which the human eye can't see it. And they emit light through tiny holes that come across above them, and they emit the light to this phototransistor cell. That's all it is. So they just shine light through 360 slots on the outside, and maybe, I don't know, 8 slots on the inside, depending on how it's designed. But the problem with these devices are they had high failure. A lot of times, they put them inside distributors mostly, right? And what happens is they're exposed to 2 elements. One of them is contamination of oil and antifreeze. I mean, I get a guy go, oh, well, I'll put some electric cleaner, spray it out, put it all together, we're done, boom, starts up, he's done. Because what happens is you get this scenario. Where the holes are filled, you get no activity, no up and down. But here's the thing, it's going to come back. How did the oil get in there in the first place? The shaft is probably worn. So understand, these things are okay, but they're in bad areas. They can drop out, get heat up. Usually they fail from heat, and they can drop out. And here's another interesting one. When you look at a scan tool, the computers look at the sensor inputs, and this is not more than a food processor. That's what it is, it's a food processor. It processes information, then you look at your scan tool, and that's the end result. If I'm looking at a scan tool, and I see RPMs, because I'm looking to see if my RPMs are accurate, and I see RPMs go from 700 RPMs and spiking almost 5,000, and I don't hear the engine on the 5,000, I have a problem with that. The car is running kind of erratic, and also I see 5,000 RPMs on the scanner a couple times in a row, and it goes away. This is why you need the graph stuff. I'm like, how's that happening? It's all about the input. It's probably a bad input, not a bad ECM. You see that little tiny spike? The computer only knows this. Boom, 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 boom. Who's this guy? He came to the party. So it sees it as an acceleration of speed. But here's the thing about these sensors, where they're located. It's very bad environment. Who's right above them on the second floor while they're down here? The little spark jumping around up there? That's secondary voltage, which create electromagnetic interference. You imagine being down there working, doing your job going, oh my God, the dude on the second floor, he's dangerous. So what happens is, if you have a bad plug wire, and it can't go in the cylinder, I mean, look, I'm spark, and I'm going, okay, I'm going to go through the wire, no problem, I'm cool with that. Now I'm going to jump the spark plug gap, but dude, it's hot in there. And look at that. Look at the gap I have to jump. And look at the compression. Look at that big sucking, that big piston coming at me. It'd rather go the opposite direction. Electricity goes the path of least path of least resistance. And what happens is, it can spike the sensor and create erratic output of sensor. And all this was here was a bad plug wire. Had high resistance. It wasn't burnt to a point where it created a misfire all the time, but it created a problem with the sensor, which created a problem with the computer, who didn't understand what was going on, and the output was what you saw on your scanner. So as you understand that RPM inputs, it all depends on how the shaft is turning, how the sensor is doing its job, and what is the sensor actually reading, and also is it exposed to any type of EMI, electromagnetic interference. One thing too about sensors, RPM sensors, we need this. We need to have synchronization of sensors, because computers need to see them lined up. We talk about trigger wheels moving. So let's talk about this here. Here, crank pulleys. You don't think a crank pulley with a keyway can shear and move the crank pulley, which has a trigger wheel attached to it? You know what Ford made these out of? Aluminum. Then they put a cast iron sleeve around the outside. You know, when I was a kid, I had a Chevy Camaro, small block Chevy, and my pulley, the oil ring actually got so hard like a car bit and tool, and it made a big groove in my pulley. I didn't want to spend money for the pulley, and I knew they had shims. So I bought this shim, and I pressed the shim on, brand new pulley, stuck it in. I'm like, that's cool. And I'm thinking, they must have had these things left over from back in the 70s, and they sold them to Ford. That's what they did. Because I know these sleeves. I've seen them. I pressed one on. Bad design. Here's another bad design. Crank pulley actually broke and spun. The crank pulley broke in half and spun on the shaft. Imagine that. That thing wobbled, by the way. My eyesight nailed it to the cross. He had a hard start backfiring. I'm like, dude, you notice that pulley's wobbling? Well, I didn't look down there before. Oh yeah, dude, I'm done. I'm done. I was done with that diagnosis. Key thing is eyesight and hearing backfiring. Doesn't always happen in the front. It can happen in the rear. Look at it. I call this a cookie cut syndrome. Look at the center of this flywheel. It cracked and spun and held. And this flywheel did make a funny noise at times. But can you imagine the trigger wheel is on the back of the flywheel? And I've seen guys, I'll go a step further, that some of these flywheels can go on 6 different ways. I said to the guy, you took it off, you didn't mark it, and you put it in the wrong spot. Because when he started the car up, it was running like, it was misfiring, wasn't running too good, and I saw that the advanced timing on the camshaft, because it was calculating advanced timing, on the scan tool was at like -45. And I'm like, should be at 0, because there's nothing being applied to move the cam gears, because it had variable valve timing. Put these guys back where they belong. You take these things off, if you got a trigger wheel, you better put that flywheel on the exact same spot you found it. I've seen many guys screw that up. Pins, sheared pins. There's no guarantee if this gear is in place and the guy goes, the belt's on the money. Dude, that's belt orientation. Your shaft spun in the gear. Your gear orientation's off, right? You're checking the actual belt orientation, but you're not thinking about what can happen to the shaft. Same problem here. Look at this here. Look at that. See it? shaft turned in there. On this cam gear, as tight as that bolt was, trying to take it off, I was surprised when I took it off that it had that. Mesmerized by that. This one here I'll skip over. No big deal with that one. And here's another one. You guys, you put a motor in, right? You did a beautiful job. You get done, it doesn't start. No spark. But you got to be visual. When you're doing stuff, the guy sold them a motor that was 1 year off. Same engine, everything was perfectly identical, except for, here's the pattern it made. Look at the trigger wheel on this crank. A little different. No one looks. So you work on the engine up top and no one does one of these. You have to put the pan on. You need to really check this stuff because a lot of guys now are swapping engines, putting used motors in because you have to save people money. You buying something used, you better make sure there wasn't a change from 1 year to the next because they'll make changes. And the reason why they change trigger wheels from year to year is because they want to change the strategy of this guy. They want to change them up a little bit. And then they write software to adjust for it. Just for better performance, maybe better fuel economy, whatever they want to do. But they can change, they're allowed to change trigger wheels every single year. They're allowed to do it. And they can do mid-year changes. So be careful when you're putting parts in vehicles. Check these trigger wheels. Another situation, I've seen this many, many, many times. Chrysler changed their cam trigger wheels. I'm here to tell you in 99, 2000, and 2001. Same motor, 2.7. They changed it in 99, 2000, and 2001. It's unimaginable. So guys are going to put a used motor in, it won't start. But here's a trick. A little trick for this year, make, model engine, and may work on other cars. You can pull the actual cam sensor out. Just pull the connector off. Crank it for at least 15 seconds. It sees no cam signal. It goes into backup strategy. It will start the car and run. As long as it's unplugged. Plugged in, it goes, I don't know what to do. I don't know what to do. If it doesn't say, it goes, no problem, dude. Plug a value in. We'll hit this puppy real fast, random times, and we'll get it right. Like playing Russian roulette, and the car starts up. Nissan. I am totally amazed at their strategy. You could take the crank sensor off the engine on this, I don't know, I think it's a 1. It's a 4-banger. I forgot what size motor it is. It could be a 1.8. You could take the crank sensor and unplug it off the engine. Boom, it starts up. I'm like this. How does that work? And it sets a crankshaft sensor code. I said to the guy, dude, something going on with the crank sensor. No, I'll bet you didn't plug it in right because it has that stupid green connector lock. You can never get it back in place. I'm here to tell you. You yank it, you have to push in and pull out. He never placed it in right. It popped off. Wasn't fully seated. That's all it was.
Yeah, but how that started? Look just at the cam sensor?
Well, you know what it did? It's got a strategy. It can look at the cam sensor, and what they do is it plays Russian roulette. It just keeps hitting it till it hits it right and the car starts up. I've done that with cam sensors that are bad. The guy's cranking the engine, I know the crank sensor's working. I take the cam sensor signal, and I keep, the 5-volt line, and I keep grounding it real fast, and boom, it'll start up and it runs, because I hit it just right. You can do that. That's what computers do. They play Russian roulette. But that I know on Nissan for a fact, it will start up, unplug it, try it. Crank it for at least 10 to 15 seconds. It'll start up eventually. I've had it, and I'm mesmerized by it. But very good strategy on their part. Very good strategy. We talked about driver circuits, all right? Basically what it is it's going to look to make sure 12 volts comes in, and it's going to ground the circuit, and there's one guy inside. His job is to go, okay, ground it, and it's high, go low, and he goes low. Every driver circuit has to go from high to low if it's a grounding situation, not one that pulses it. So the computer has to see first if there's 12 volts. Before it commands drive operation, it has to see 12 volts. When it commands it off, and then when it grounds it, it has to see it go low, and when it commands it off, it has to see it go back high. If it doesn't go according to the command, it'll set a driver code instantly. And here's one. This will blow your mind. I've had 4 already. The first one blew my mind. I'll zoom in a little bit. The vehicle operator may experience headlight fluctuation on a Chrysler 300 2005 and or interior lamp fluctuation. This condition will occur after cold start while the vehicle is idling under heavy electrical load. And slight throttle tipping. This condition can also be described as headlight and interior lights changing intensity. This guy says sometimes I'm at a light at night and also the lights start flickering. I changed the alternator. So that same problem, the flickering. He goes, car's got to be programmed. I'm like, what are you talking about? He goes, yeah, you got to program the car. So I pull up this Bolton and you have to program the car. And I'm like, I'll give it a shot. I put brand new software in it and it fixed the driver failure of the alternator. And I'm like, dude, this is another case of automotive menopause. What happened? The car ran for 60, 70,000 miles. All of a sudden now the driver decides, I don't want to work no more. And it wasn't a problem with hardware. It was software. So now I know that software can fix driver problems. It can fix monitors not completing. It can fix all kinds of problems. I even had one the other day where it lost the ability to learn the keys in memory. It's supposed to have it's supposed to have non-volatile memory. Remember the keys. It dumped memory in the keys. And I found a service bulletin to program the ECM so it remembers the keys. I don't know. Automotive menopause. I'm going to coin that. No one take that. I'm coining that phrase. And here's the one I was telling you about where the harness short out an exhaust manifold and created a driver circuit low. And here's another situation where driver circuit low, where a pin actually got melted and destroyed on this air pump solenoid, deteriorated. So that created the open circuit because 12 volts went in and didn't come back to the ECM. So an open circuit sets driver circuit low. That's an open circuit, whereas the other one was driver circuit low external where it was shorted. So computers don't know the difference between a short or an open circuit. They just know it's low. And what caused this failure was what? This is attached to a piping that goes to the exhaust manifold, this air pump. The air pump comes in, this solenoid opens the gate, allows the air to go to the exhaust manifold. So how did this guy get damaged? He just, what? Bad check valve in the exhaust manifold. You see all this stuff, you better figure out what caused it. So a bad check valve, one-way valve, the exhaust came up and damaged everything here. So if you see something that's bad, find out why it went bad. How are we doing on time? I don't want to keep you too long. Oh, good. We're doing real good. Check engine lights have a lot of strategies. How about this? No codes, and you know the answer. No codes. You have your machine hooked in, and the check engine light's on. Oh, no, sorry. The airbag light's on. Or the ABS light's on. You disconnect your machine, the light goes off. What's going on there? Why is the light on when your machine's hooked up and you're talking to the car? Because that's what it does. You know, when you're talking to somebody, they have their eyes like this. Hey, how you doing? Right? It's the same way. When you're talking to a controller, certain controllers will actually put the light on. Because, you know, I got done with the car, there's no codes, I fixed it, I cleared the codes, I'm like, the light's still on. Dude, take the scanner off. The light's still on. Take the scanner off, the light goes off. So understand about light strategy. They can also be on and set codes, and they also can do stuff such as this on a Subaru. Look at that light flickering away. With the car running, that light's flickering all the time. It ain't misfiring, just flickering. Just flickering away, right? Turns out, and I hate Subarus. I really do. I just put the new software Subaru up to 2012, and there's still really no bidirectionals. For years and years and years, they've never really had bidirectional control in their scan tool. What they do is they use this stupid green connector underneath the dash. They say, go underneath the dash with the key on, turn the key off, hook up the green connector, turn the key on, and we're going to ground everything in the car. Everything we can. So you hear the fan go off, ooh, ooh, on, off, you hear all kinds of clicking, the AC clutch is going on and off, everything starts to click. That's their output cycling test. And the check engine light starts to go crazy. So when I first saw this car, I thought it was a bad ECM. I checked all the grounds, and, you know, power and grounds, and it's going nuts, you need an ECM. Put an ECM in it, still same problem like this. What do you do now, dude? I don't know, you made the call. Dude, I'll call a friend of mine who works at Subaru. He said to me, go into Dash and look for that green connector. It's probably plugged in. Unplugged it, problem's gone. Light strategy. I didn't know light strategy on this car. We had to bury the hatchet in this job. And we blamed it on the last shop who left it plugged in. It's his fault that we spent money for this customer, but the car's fixed. We both learned. It was a very expensive mistake. So understand light strategy. And also too, if a driver does not work, you can force the driver to work. Because, you know, there's certain situations where the driver may not work. It may not be forced not to work. But you can command it to work and say, look, I know you see something you don't like. I'm going to command you to work, so I know you work. So hence, your bidirectional controls in your scan tool. You have to use it. Put the fan on. Put the air pump on. Command stuff to come on. I mean, I'll give you an example. I had an air pump code. It said air pump circuit fault. So I get on there. I go like this. Boom. Ooh. Nothing wrong with that. Did it again. Ooh. So the computer is grounding the relay. The relay is engaging the contacts. The pump runs. It got to be an ECM. What else would you do? Keep setting an air pump circuit fault. So what would you do? It works every time I command it. It's something the C doesn't like.
Make sure there's air coming out of it?
No, it was an electrical problem. It said it was a driver circuit error. It just said air pump driver relay circuit failure. I'm like, can't be, because I'm grounding it. It's working. So what would you have done? Would you have replaced the computer?
Possibly, yeah.
Possibly. I mean, I had no other shot to go.
It works when you command it up.
Right? Because the guy said to me initially, his air pump didn't work at all, so he put a pump and relay in it, and now he's married to this other problem. I think maybe he was poking around. So he put a computer in it, same problem. Oh my God. You know what he did? He bought a relay aftermarket, and it was an electronic relay. It wasn't a regular standard field coil relay. The field coil relay has 12 volts go through the winding, and then the computer goes 12 volts high, grounded. This sucker had 5 volts. So the computer still grounded it. It came on, but it was 5 volts. It wasn't 12 volts. I'm like this. Oh my God. This dude sold an electronic relay that didn't belong in the car. It worked, but it was wrong design. Let me tell you something. That one kicked my butt. Until I actually read at the computer, I looked for 12 volts. I'm like, 5 volts? It's a high resistance? Wrong relay. Electronic relay. Beware of that. Need your solenoids, need your monitors. I want to go into driver circuits. Here. Do you know that when a computer gets all these tasks of grounding solenoids, relays, it also has to ground circuits that draw a little more current, such as injectors. Injectors can draw, especially low impedance injectors can draw a lot of current. They can draw as much as 4 amps. So what they do is it takes more to open the puppy than it does to hold it open. So it's the first initial pull, right? It'll ground it down here. It pulls it up. See, now look how far it's grounding it. That's 4 amps. Then it kind of releases it to another level to hold it open. So there's more current here because it's grounding it here. Pulls it up here. So it's like a peak and a hold. But see how the current rises? So here's the peak and the hold. Now understand, that's 4 amps to open that puppy. 4 amps. How would you like to use a Noid light on a car with that type of injector? Well, it's hard to see, but my Noid light is flickering. It's hard to see, but the Noid light is flickering. So I'm like, the driver's working, so it's got to be something going on with the injector. So we checked I went in there and triggered the injector myself. I'm like, I don't know, I'm putting straight 12 volts and ground to it. I put my Noid light on there, and Noid light's blinking. I put the injector connector right on, and there's no injector pulse. So I thought maybe there was something going on with the injector. Put the injector in, same thing. And that's just showing that the Noid light was pulling about 700 milliamps. This puppy pulled about close to 4 amps. What the problem was? The driver inside the ECM was no good. It was able to work my Noid light, but not the injector. I didn't know, and you got to watch out for that too, because if the ground is bad, remember, computers have to take the ground side of the circuit, and they have to ground that field coil all the way to ground. So if the ground is bad, right, it can't ground it all the way. So you better just check all your grounds first. If they're all good, then the problem is the driver inside the ECM. Because you can go to the ECM yourself and ground it real quick. Just ground it real quick to see if you get 4 amp pull. But don't hold there too long, because you could damage the injector. Understand that drivers have to control how long they're going to ground something. You don't just sit there and go like this and hold it. You ever ground if you do an amperage check on any solenoid, let's say the solenoid pulls, let's just say it pulls 1 amp, right? I ground it, and I was like, all right, 1 amp, all of a sudden it goes 0.9, 0.8, 0.7. Why does it keep going lower in amperage the longer I hold it there? What's that solenoid doing? It's getting hot. What happens when you induce heat into that solenoid? Resistance. Current drops. So you're going to get an invalid reading. If you just sit there and hold there, it's invalid. Just do it one shot real quick. You'll see how many amps it's pulling. But don't hold it there. Your job is not to hold it there. And they also have low impedance injectors. These are higher resistance injectors. Regular port injectors, they take 2/3 of operating current to open, just so you know. And so it could take 0.6 amps just to open it, and almost 0.9 amps to fully get it open. So a Noid light, if a Noid light takes, let's say the Noid light is taking like 0.3 amps to light it up, there's no guarantee you open an injector. You ever have the old Nissans where you're doing a tune-up and all of a sudden the car's misfiring, you have to wiggle the injector to get it to work again, and you find out it's all corroded? That resistance prevents it from firing. It's high resistance. So they had to replace all their connectors because they were all corroded up. They all got gangrene. So just understand, a bad connection can give you a misfire because it needs 0.6 of a volt to open. And look at this puppy. Guy goes to me, oh, the car won't start up. When it gets real hot, it won't start up. And he goes to me, and I got a really, really weak pulse. Let me put my scope on it. I'm checking it. Here's the computer grounding the injector. I'm at 3 volts. I'm over here. So why is the computer not going all the way down here? It's only grounded to here, 3 volts. So I'm thinking, it could be a bad computer that can't ground it all the way. It could be a bad ground. But here's the problem. We're only looking at voltage. That's the problem. You need to look at amps, because the other part of Ohm's law is the amps. Look at this. It's pulling 13 amps. So the computer's going like this, right? The computer's going like this. Okay, who's your daddy? Who's your daddy? Who's your daddy? Whoa, you're my daddy. It don't want to pull, because it knows it brings it all the way down to ground, it's going to burn itself out. So it's going to hold it at a certain level to protect itself. That's a smart driver. Now here's a dumb driver going like this, like that IAC control motor or the motor mount driver. Grabs a holder, goes, oh my God, oh my God. Goes, let go, dude. No, they didn't tell me let go. They told me to hang on for the ride. Meanwhile, the new smart drivers do this. Oh, no problem, dude. I'm cured. I can hang on to you, but I'll just elevate myself. So those are smart drivers. Smart drivers can prevent the car from can prevent itself from being damaged. And understand that you can't just look at volts. You look at the amps. You have to look at both. That's done with an amp clamp, by the way. And power management is another thing I want to talk about. Computers have the power they have the properties to manage your power. And the way they do it is they shut down injectors. I'll tell you different scenarios. Hey, you could be driving along, and all of a sudden, you can have a partially clogged cat on one side, and all of a sudden, you'll get that little light flickering, right? The computer's going to say, one side of the engine is not doing too well, it's misfiring. I'm going to shut down all the injectors on that one side of the engine, or I'm going to shut down cylinder 3 and 6, because that's the ones that are really misfiring. It shuts them down. Now you slow down, you stop, and the engine's missing. So you get out and you go, wow, these injectors aren't working. Huh, could be something on the computer, that's why I have a miss. Then you shut the car off, you count to maybe 10, start up, miss is gone. You drive it again, same thing. You go, let me replace the computer. Meanwhile, you have no idea that the strategy is for the computer to shut down the injectors to protect any more damage to the cats, because it sees a misfire. So they can do that. Also, on transmissions, if the pressure control solenoid has a problem in the trans, especially on the Fords, the computer will shut down half the engine. It'll shut off half the injectors. The minute you try to put it in gear and drive away, you're not driving nowhere. It's going to prevent the car from accelerating because it wants to protect. Its job is to protect the transmission. Its job is to protect the catalytic converters. Another thing too is, you ever see like a Nissan like this? At idle, the idle's too high. So what it does is shuts down half the injectors and does this with the injectors to maintain low idle. If it didn't, it'd be revving like this, wah, until you figure out why the idle's too high. Another thing too is, if you go faster than, let's say, you want to go, all right, I want to go 148 miles on my Caddy, but you can't, because when you get to a certain vehicle speed, it will shut down the injectors. It will. It'll prevent you from driving too fast. That is power management mode. Power management mode is a very crucial thing. There's your cats we talked about. Coil drivers, kind of like the same thing with the ramping of the current. And here's one story I'd like to be told. One thing about a driver is that when the driver's applied, it's a slow building up of current. It's controlled. It's controlled. It's the peak and then the hold. You see the voltage trace? It was here, then it lifted up. But look at this. You see this nice release? You have to release the circuit right away. And that creates the induction into the secondary. You ground something and release it right away, you get the induction. That's how you get secondary voltage. So here's a guy that had no spark on a Toyota, and what he did was he replaced the module. Still no spark. Replaced the distributor. And what it ended up being was a coil, because they go bad all the time, those coils. This particular year, make, model, 93 Toyota Camry, 5 SFE, tons of coils go bad on them. So he replaced the distributor, starts up, he's like, yay, I found the problem. After replace 2 parts, customer takes the car, come back, says, my car's hesitating. So now he starts checking the TPS, replace the TPS, because it does, it hesitates. Whoop! Has that little hesitation in it. But what does it realize that when you open the throttle wide open, it gets a lot of air. And it has to get a lot of fuel. And it better have a lot of spark, because a lean mixture, when you open the throttle wide, okay, you're introducing a large volume of air. You need more spark. You actually need 21,000 volts just to crank a car to start it. You need about maybe 10,000 volts just running, idling. But the minute you snap a throttle, you need a lot of KVs. KVs will rise on a snap. So I said, let's just put a spark tester on it. I want to check your KVs. I checked it. Anybody have a spark tester? I've made a lot of money with this thing. It's only like, I don't know, 10 bucks. It's an HEI spark tester. There's no center electrode. It will force the system to put out about 25,000 volts. So you can't do this and go, I have good spark. Yeah, it's like blue. It's not orange, it's blue. I'm like, dude, that's back like in the 50s, 60s, dude. That stuff is gone. You need one of these. So I put a spark tester on it. So you got weak spark. So either it's a bad coil or the driver is not doing its job. So I go over here, right? I put my spark tester on it. And what do you notice about this pattern? What? The release. It's all about the release. And I'm going to tell you here, this driver was in love. It did not know how to let go. It did not let go. And because it did not let go, this is brand new igniter. That's what pissed me off. Brand new part from the auto store. I'm not here to knock auto stores. I'm just telling you that it was an aftermarket part. I've never, ever seen one of these igniters go bad. Never, ever, ever. In all the years I've been out there, never seen one. So I said, dude, give me the old igniter. He happened to have it. I plug it in, and I got this. I could not believe that it was engineered. It had a problem with the driver in a brand new module igniter assembly. And that's what the problem was. You have to, if you don't release that circuit, Any driver, when it gets done holding it, it has to release it. That's just the way it's going to be. So driver circuits, that's what it has to be, and that's what the problem with that is. And I want to go over this real quick, real briefly. A, it's all about the box, what it is. It needs powers and grounds. It will feed reference powers, reference ground out to all the sensors. The sensors feed it information. With the information, through its strategies, it applies devices. It's that simple. Keep it simple, guys, and I hope you really enjoyed the show tonight, all right? And with that, you can go home now.